Hi everyone, my name is Dr. Philip Prins. I'm an assistant professor of exercise science at Grove City College. A little bit of background information about myself. I got basically all my degrees in exercise science, kinesiology, exercise physiology. That includes my bachelor's, my master's, and my PhD. However, I've always been interested in nutrition. So I got my minor in nutrition, and again, every opportunity that I ever got in grad school to take a nutrition class, I took that class. So it's a real passion of mine, and that's really most of my research over the course of the last couple of years has been nutrition related, specifically how nutrition impacts health and how different diets impacts human exercise performance. Also, if you have any questions, feel free to contact me. I included my Twitter handle and also my email address. So the topic of this presentation is called The Great Dietary Deception, and I hope you enjoy it. Alright, so I'm going to start off just talking about some basic nutrition. So nutrition 101, just looking at the macronutrients, carbohydrate, protein, and fat. Then we're going to look at how important is one's diet in determining your optimal health. We'll look briefly at the Dietary Guidelines for Americans, meaning so what does the government say in terms of how we should be eating. We'll look at compliance to those dietary guidelines. So have we been compliant? Have we followed those dietary guidelines? Then we'll jump into and look at some health statistics. And then we also look at the evidence for the dietary guidelines. And then lastly, we'll finish up by looking at what type of diets or foods may be ideal for most people. Not all people, but what does the evidence say regarding what type of diets or food may be ideal for most people. So before we get started, I wanted to share you a quote from Barry Marshall. So Barry Marshall is an Australian physician and also a Nobel Prize winner for the work that he did that showed that the bacteria H. pylori is the cause of most peptic ulcers, and this reversed decades of medical doctrine holding that ulcers were the cause of too much stress, spicy foods, and too much acid. He said that every generation of medical students is taught at least one utterly wrong fable. And I think we can delete the word medical students and just rephrase that by saying every generation is taught at least one utterly wrong fable. And that's going to become a theme for this presentation. I'm here to tell you that you have been told a lie for the past 4 to 5 decades. We have been told that in order to be lean and healthy, we have to avoid fat, especially saturated fat, and eat a bunch of so-called healthy carbohydrates. And this all started back in 1977 when the first dietary guidelines for Americans were conceptualized. Seems like a great idea, however, has it actually worked? And these are some of the topics that we will explore going forwards. Alright, so let's start off with some basic nutrition information. So let's look at the macronutrients. Right, so you have 3 macronutrients. So there are 3 primary macronutrients: carbohydrate, protein, and fats. And these macronutrients, which we all consume in different quantities, depending on what your diet looks like, that it is these that are going to provide us with the bulk of the energy, say to sustain basic physiological metabolic processes, say your resting metabolic or your basic metabolic rate, or say to fuel your exercise performance if you are regularly physically active. So let's talk a little bit about each one of these in a little bit more detail. So first off, carbohydrates. So carbohydrates, and examples of carbohydrates or high carbohydrate items include, say, breads or cereals, grains, fruits, vegetables, pasta, rice, potatoes. Those kind of items are typically higher in carbohydrate content. Their glycemic index or glycemic load is typically high. So when those carbohydrate items are consumed, they are rapidly broken down to glucose. And that's going to raise your blood glucose or your blood sugar level. Now, an interesting fact is you only have an equivalent amount of about, say, 2 teaspoons of sugar that's in your circulation. So about, say, 5 grams or so of glucose is in your circulation, is in your bloodstream. So obviously you can imagine if you sit down and you eat a high carbohydrate meal, that will in turn raise your blood sugar level. Now, your body is a homeostat. It likes homeostasis, which is a constant internal environment. And you can see that if you look at heart rate or blood pressure or blood sodium levels, your body core temperature, etc., etc., etc. So if your blood sugar levels goes up, your body doesn't like that. It wants to get back down to normal levels. So in this case, it will secrete the hormone insulin. And insulin, one of insulin's jobs is to facilitate the uptake of glucose back into the cells. So say back into muscle cells or liver cells. And so insulin is going to continue to be secreted in large amounts until the glucose that's in the circulation is lowered back to normal levels. Okay, and that's how it works. And then that glucose is that's being, say, transported, say, to the muscle or the liver, is then stored there as glycogen. And glycogen is just a storage form of glucose. So that's how it works. Now, some people say that your brain and nervous system and muscles are fueled mostly by glucose, and so therefore carbohydrate is the main energy source. When you look at carbohydrate, proteins, or fat, that carbohydrates is the body's main energy source. So therefore, a continuous supply of carbohydrate is necessary to prevent body stores from being depleted. And if you were to eat too little carbohydrate, that would lead to low energy levels and fatigue, and that could then also impair your exercise performance, since your glycogen stores would then be low as well. So therefore, according to that train of thought or that model, then proper management of amounts, types, and timing of carbohydrates required to fill and kind of refill your carbohydrate gas tank, or to make sure you eat plenty of carbohydrates to stuff your liver and muscle with as much glycogen as possible, so that you have enough glucose going around to fuel your muscle and brain and nervous system. So the question is whether that's true or not, and the answer is no. That's not true. This whole idea that carbohydrates is your body's main energy source is not true. That is true. Let me rephrase that. If you eat carbohydrates, right? So if you eat a high carbohydrate diet, then yes, then your body is going to use a lot of carbohydrates. However, you can find plenty of studies where people do the opposite, and they restrict their carbohydrate intake, and they eat, for example, a low carbohydrate diet. What happens? Do they have low energy levels? Do they get tired, fatigued? Is their exercise performance impaired? No. What happens is their body switches over fuels. Instead of burning carbohydrate, they start burning fats. So the primary fuel that their muscles will use are these free fatty acids. Now, in terms of the brain and nervous system, they start using these ketone bodies. For example, beta-hydroxybutyrate or acetoacetate. And those are just kind of byproducts that's produced in the liver as a byproduct of enhanced fat oxidation. So this notion that carbohydrates is the body's primary or main energy source is not based on any good science. Your body is good at adapting. So if I decide to eat a bunch of carbohydrates, I'm going to burn a lot of carbohydrates. If I decide to restrict my carbohydrate intake, my body will switch over and start burning fats for fuel. Okay? So there's some basic information with carbohydrates. And I think one more thing I'll add to that is there's no such thing as an essential carbohydrate. We'll talk about proteins and fats here next. I mean, there's such things as essential amino acids and essential fatty acids. So it's important that you get a certain amount of protein and fat on a daily basis to help with growth and development. But there's no such thing as an essential carbohydrate, meaning if I want to, I can ingest 0 grams of carbohydrates per day. It's kind of hard, but but that is true. I mean, there's no such thing as an essential carbohydrate, so I don't have to eat dietary carbohydrate in order to function properly. And one of the reasons for that, or the primary reason for that, is your body is pretty good at gluconeogenesis. And gluconeogenesis is just converting non-carbohydrate items to carbohydrate items, say to glucose. And so, and again, that's what typically happens with individuals who eat very low carbohydrate or ketogenic diets. Is, you know, for those individuals, say 60 to 70% of the energy that's being supplied by the brain is coming from these ketone bodies. So it's still, you know, maybe up to 30% of the energy is still coming from glucose. However, that's not coming from ingested glucose. It's coming from what's known as gluconeogenesis. So you don't have to eat carbohydrate for your body to make carbohydrate. I think that's the big point. All right, so protein. You can think of protein as more as kind of the building blocks. So muscles and other body tissues are made up of proteins, and you know, although protein contains the same amount of energy as carbohydrates, so both contain 4 kilocalories per gram, its primary function is not energy. Its primary function is more growth and repair of tissues. So it's not an efficient source of energy. If you're looking at energy, where does the energy come from to supply say ATP at rest or during exercise? It's coming from either carbohydrate or fats. Protein is, yeah, it's very important, but it's important for other reasons. Like I said, growth, repair of tissues. And again, you have you know, protein kind of broken down to amino acids. You have non-essential amino acids, and then you have essential amino acids like leucine, isoleucine, valine, these branched-chain amino acids, which means, again, it's important that you get an adequate amount of protein in on a regular basis, especially if you're an athlete. Or if you're regularly physically active. Very important that you get at least, say, between 1.6 and 2.4 grams per kilogram of body weight of protein in on a regular basis to help for recovering and, again, building muscle, repairing tissue, etc. And then obviously examples of protein includes more animal products. Those are examples of complete proteins, but you can get also plant-based proteins as well. In addition, you know, last thing with protein, right? Protein is also a very saturating, if not the most saturating, of the 3 macronutrients. And then lastly, fat. And you know, examples of fat will, you know, include, say, butter or olive oil or coconut oil, but a lot of animal products contain fat. And you, in terms of fat, you have, you know, saturated fat and then unsaturated fat, which will include your, you know, polyunsaturated fat and your monounsaturated fats. And in terms of energy, you know, fats is the most energy dense. I mean, you get you know, about twice as much of energy from fat compared to carbs or proteins. I mean, you get 9 kilocalories per grams of fat compared to carbohydrates and proteins. And again, you have such a thing as essential fatty acids, right? So dietary fats are essential to health because they help deliver vitamins, minerals, and nutrients needed for normal growth and functioning. So it's very important that we get enough fat in our diet on a daily basis, again, for proper functioning, for health and wellness. However, again, some people believe if you eat too much fat in your diet, that, you know, that's going to, number one, make you fat and gain weight, and it's also going to negatively impact your health and your exercise performance. And the idea behind that stems from the fact that, well, again, you know, fat is more energy dense to these other macronutrients, right? So if you eat more fat, then your energy in is going to be greater than your energy out, which is a flawed premise to begin with, but that's kind of where that comes from, the whole calories in, calories out model. And that's one of the reasons why fat was kind of demonized from a weight perspective, because it's more energy dense, and from a health perspective, because we have this belief that you know, fats, which includes, you know, saturated fat, and also you know, animal products that contains more cholesterol will clog your arteries, leading to, say, a heart attack or a stroke. And that's kind of the premise of the diet heart hypothesis, right? So if you eat more saturated fat or, you know, dietary cholesterol, then that's going to you know, clog up your pipes, so to speak, your arteries, and eventually you'll succumb to a you know, a cardiovascular event. And as we see later, that is also not true. And then from an exercise perspective, the idea here is that, well, if you eat too much fat, then you're going to eat too little carbohydrate, because normally those two kind of go hand in hand, right? If you eat a lot of carbohydrate, if you eat a high carb diet, you typically eat a low fat diet. If you eat a low carb diet, you typically eat a high fat diet. So if you eat too much fat, then you eat too little carbohydrate. And so the idea in terms of sports nutrition is that, again, carbohydrate is supposedly your main energy source, so therefore your glycogen stores will be low, and that's going to negatively impact your exercise performance. That's going to lead to then fatigue or kind of hitting the wall because depletion of your glycogen stores. That's a separate topic that I'm not going to address in this talk because that focuses more on sports nutrition, but there's been a couple of great studies that have come out recently that have shown that's not actually the case. And you can go look up works from Jeff Volek and Jeff Volek's lab, and in addition to Stephen Finney, the work that he has done, and Dr. Tim Noakes have done some great work in those areas. But in any case, so those are your macronutrients, carbohydrates, proteins, and fat, and some basic information regarding those macronutrients. So a really important question is what foods or diets should we be eating on a habitual basis? I mean, there's so many different foods out there. There's so many different diets out there. You have a high carbohydrate, low fat diet. You have a low carbohydrate, high fat diet. You have Mediterranean diets. You have Atkins diet. You have Zone diet. You have South Beach diet. You have Ornish diet. All kinds of different diets that are out there. So this is a really important question. What foods or diets should we be eating in the long term for optimal health? So why exactly are the foods or the diet that I'm consuming on a regular or habitual basis so important? Well, the reason why it's so important because whatever your habitual diet looks like, whatever foods you're consuming in the long term, that is what's determining your state of wellness or illness. Recent research has showed that poor diet now generates more disease than physical inactivity, alcohol, and smoking combined. Other research have showed that poor diet is responsible for almost 1,000 deaths per day. So it's almost like a quiet crisis that is happening right under our noses. We have decades long of healthcare debates, but we ignore the number one cause of poor health, which is our diet. So what type of diet does the US government recommend that you eat? So the Dietary Guidelines for Americans was developed jointly by the Department of Health and Human Services and the United States Department of Agriculture. And they provide recommendations in terms of how you should be eating to stay lean and healthy, right? That foods that may reduce the risk of major chronic diseases like obesity, heart disease, etc. And they was first published in 1980. And the dietary guidelines are revised every 5 years. So there's been another edition in 1985, 1990, 1995, 2000, 2005, 2010, and then the last edition came out in 2015. And really, if you look at the dietary guidelines, really not that much has changed since the inception of the dietary guidelines in 1980. So the U.S. government, and also I can add probably much of academia, has consistently recommended lowering the dietary percentage of fat and saturated fat, as well as the absolute levels of dietary cholesterol, based on this theoretical link between those food components and a higher risk of coronary heart disease. And so the typical dietary recommendations based on the Dietary Guidelines for Americans is that percent calories for in terms of protein is 10 to 35%, fat is typically between 20 and 35%, and carbohydrate intake should be somewhere between 45 and 65%. So As you can see, this is essentially a high carbohydrate, low fat diet. Whether you look at the traditional food permit or whether you look at myplate.gov, it is a high carbohydrate, low fat diet. And these recommendations were considered to be beneficial for the prevention of overweight and obesity, along with diabetes, cancer, and other chronic diseases. So it seems like a great idea. I'm sure the intention was well-mannered. Because before 1980, there was, just to be clear, before 1980, there was no dietary guidelines. So the government never stepped in, never told anybody in terms of how to eat. So people just did their own thing. But since 1980, right, every 5 years, we've had these dietary guidelines that inform people what foods to eat if you want to be lean and healthy. So again, it seems like a great idea. However, the question is, what has happened since 1980? Have we become leaner and healthier as a result? So if you're sitting there right now and you're going, so what? Who cares about the dietary guidelines? Nobody reads that document in any case. It doesn't affect me. Well, in that case, you would be wrong, because the dietary guidelines actually does affect a lot of people, either directly or indirectly. So the guidelines inform government nutrition assistance programs, which touch 1 in 4 Americans every month. In addition, they're also the single biggest expense at the United States Department of Agriculture. And they include the National School Lunch Program, Supplemental Nutrition Assistance Program, for example, food stamps, a Special Nutrition Program for women, infants, and children, so WIC, and also feeding programs for the elderly. In addition, the guidelines also help determine the content of military rations. Further, the guidelines help guide the FDA regulations on food, including the information on packaging. Basically, in summary, the dietary guidelines are probably more influential than any other single factor in determining what we eat. Alright, so what we have learned up to this point in time is that it would seem that the Dietary Guidelines for Americans is a very important document. It affects a lot of people directly or indirectly. So the next obvious question becomes, are we compliant to the dietary guidelines? Remember, the dietary guidelines over the course of the last couple of decades have recommended basically that we eat the majority of our calories, or that we get the majority of our calories from carbohydrate. Right, 45 to 65% of our calories is supposed to come from carbohydrate. At the same time, we're told to limit our fat intake to 20 to 35%. So if you look at the food availability data or the food consumption data, of course, the last couple of decades, what has happened in terms of our carbohydrate and fat intake? So as you can see here by the figures depicted in this slide, whether you're looking at food availability data from 1970 to 2014, or just U.S. consumption by calories, so just looking at animal foods versus plant-based foods, you'll see there's a clear trend. So if you look at vegetable intake has gone up by about 20%. Fruit intake has gone up by 35%. Grain intake has gone up by close to 30%. So these types of food items that we are told to eat more of, we have eaten more of. And for example, vegetable oil intake has gone up close to 90%, so a huge increase in vegetable oil intake, because we were told to stop cooking your food in lard and butter. That's not good, and rather use vegetable oils, because you think vegetable oils, you think, well, this must be made from vegetables. That's not true, right? It's a processed type of fat. It's a processed seed oil. It's prone to oxidation, causes inflammation. So there's nothing healthy about the fact that vegetable oil intake has increased so dramatically over the course of the last couple of decades. So at the same time, you also have to look at what foods have decreased over the same time period. So you can see red meat consumption has gone down close to 30%. Egg consumption have gone down by 13%. Whole milk consumption have gone down by close to 80%. Again, butter down, animal fats down. So these types of food items that we were told to eat less of, we have eaten less of. Right? So if you just look at the food consumption, food availability data over the course of the last couple of decades, then you would come to the conclusion that we have followed the guidelines. I mean, the plant-based foods that contain more carbohydrate, plant-based foods have gone up, and animal foods have gone down. So based upon the available data, it would appear that we have been compliant to the dietary guidelines. So here's an article published by Cohen and colleagues a couple of years ago that addresses this question of compliance to the dietary guidelines. It's entitled Statistical Review of U.S. Macronutrient Consumption Data, 1965 to 2011. Americans have been following dietary guidelines coincident with the rise in obesity. So they found that on average, adults in the United States have adhered to the government's dietary recommendations by shifting their proportional consumption of total calories from fats to carbohydrates. And that's clear if you look at their data. And I included a figure here that comes from the article. So you can see in 1965, just in terms of carbohydrates and fats, in 1965, people were actually eating more fats compared to carbohydrate. But you can see soon after that there was a shift, and then people started to eat more carbohydrates and eat less fat. Obviously, the dietary guidelines had a lot to do with that, and the demonization and the vilification of fat. Right? We entered a period of lipophobia, where people feared fat. They believe that if they eat too much fat, that's going to make them fat and it's going to give them a heart attack. In addition, the other findings from the study more specifically showed that fat consumption dropped from about 45% in 1965 to about 34% in 2011, whereas carbohydrate intake increased over that same time period from 39% to just over 50%. Also in 1971, saturated fat comprised close to 14% of total calories. By 2011, Americans were eating 10% of their total calories as saturated fat. And that's what's typically recommended, that you, by a lot of health organizations, that you limit your saturated fat intake to about 10% or less. In addition, the Americans have decreased their dietary cholesterol intake from over 400 milligrams per day in 1971 to less than 300 milligrams per day in 2011. Of course, that's another recommendation as it pertains to dietary cholesterol, to consume less than 300 milligrams per day of dietary cholesterol. So another recommendation that we are adhering to. Lastly, the authors also found a high correlation, close to 90%, between a change in dietary pattern and the rise of obesity over the last 40 years. And from 1971 to 2011, the average weight and body mass index have increased dramatically, with the percentage of overweight Americans increasing from 42% in 1971 to 66% in 2011. So basically, in summary, we are following the dietary recommendations. So whether you know it or not, you probably are following the dietary recommendations. So we have decreased our fat consumption, dietary cholesterol intake, and saturated fat intake. However, our compliance, it would seem, have been accompanied by a very rapid increase in obesity rates and also other chronic diseases. So coincidence? I think not. Alright, so let's quickly review what we have talked about up to this point in time. We've established that diet, your habitual diets, the food or the diet that you're eating on a regular daily basis, is crucial, if not the most important factor in determining your health. We also looked at the diet that the US government has promoted over the course of the last 4 to 5 decades. Right, and it really ever since the inception in 1980, it has promoted a high carbohydrate, low fat diet. Right, it kind of introduced the world to lipophobia, the fear of fat, and then we looked at actual compliance. Right, so that's always a very important question, because typically you hear from a lot of people that, you know, there's nothing wrong with the dietary guidelines. It's your fault because you're not following the dietary guidelines. But as we can see, if you look at the actual data, that's not the case. You know, people are compliant. Again, whether you know it or not, most people in this country are compliant to the dietary guidelines. So therefore, the next obvious question becomes, well, what has happened over the course of the last couple of decades to our health? Because one of the primary goals of the dietary guidelines was to make us lean and healthy. It told us to avoid fat, especially saturated fat, right? Because of the whole diet hard hypothesis, and also that, you know, because fat is more energy dense compared to the other macronutrients. And it told us to, us to eat a lot of, hard, healthy carbohydrates, and that's going to make us, lean and healthy. So that's why I want to look next at some statistics, some health by the numbers. So here we go. So currently, about half of adults in the United States have one or more chronic health condition, meaning obesity, type 2 diabetes, cancer, Alzheimer's, heart disease, hypertension, etc. So half of all adults have one or more chronic disease. So we have a chronic disease epidemic in this country. More specifically, more than a third of adults are obese. So currently, it's close to about 40% of adults in the United States are obese. 3/4, so about 70% of adults are either overweight or obese. So if you clump together those who are obese with those who are overweight, it's 70%, meaning if you have a normal BMI, if you are normal weight and living in the US, you are now in the minority. Right, and again, the rapid rise in overweight and obesity has raised serious public health concerns because of the association between overweight and obesity and an increased risk of a wide range of chronic diseases, whether it's cardiovascular disease, type 2 diabetes, cancer, gallbladder disease, gout, osteoarthritis, and several other conditions, as well as just increasing all-cause mortality. In addition, recent research shows that about 50% of adults are either pre-diabetic or diabetic, and that's really important. We'll come back to that later, because that's showing you more people in this country, but also globally, are what's known as insulin resistant. And insulin resistance, that's a key driver to this chronic disease epidemic. So that's a really important statistic, that the fact that we have so many people in this country who are either pre-diabetic or diabetic, meaning they are insulin resistant. Now, I would say that number is underestimated. It's probably more. It's probably like an additional 5 or 10 or 15% higher. Further, approximately 40% of men and women will be diagnosed with cancer at some point during their lifetimes. Over 600,000 people die of heart disease in the U.S. every year, and that's the leading cause of death for both men and women, not just in the U.S. but normally, typically, also globally. Something like over 700,000 people get a heart attack each year. About another a quarter of adults suffer from a diagnosable mental disorder. Anxiety disorders afflict more than 40 million. More than 5 million Americans are living with Alzheimer's. Over 10% of children have been diagnosed with ADHD. Again, over 20% of adults have arthritis. So either way you look at it, it's bad. The numbers are bad. In fact, they are terrible. In addition, data from the CDC, Centers for Disease Control and Prevention, provide new evidence that life expectancy is actually decreasing for the first time in decades. Furthermore, to delay disease progression, millions of people in the U.S. depend on medications to lower their cholesterol and blood pressure and blood glucose, and also on surgical procedures to, open blocked arteries, etc. And data from the latest CDC report suggests, and I'm quoting here, that a tipping point has been reached beyond which technological advances may no longer compensate. So we have a chronic disease epidemic. Like I said, once you get into the numbers, and again, I just showed you, there's just a couple of numbers here. I just kind of run out of space on the slide. The numbers are bad, and in fact, they are terrible. And this comes back to the dietary guidelines, because I thought this was supposed to make us leaner and healthier. And instead of everybody getting leaner and healthier, it's like the exact opposite has happened. In addition, you also have to consider the economics of the chronic disease epidemic. For example, treating people with chronic diseases accounts for close to 90% of our nation's healthcare costs. Total cost of heart disease and stroke is over $300 billion. Total cost of treating diabetes is over $250 billion. Total cost of arthritis is over $100 billion. Medical costs linked to obesity is over about $150 billion. Per capita medical spending is about $1,400 a year more for an obese person compared to a normal weight person. Cancer care costs over $150 billion, etc., 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 etc. So a lot of money is being spent on this chronic disease epidemic. And again, this will bankrupt the medical system. So whether you just look at the statistics in terms of how many people are overweight or obese or have other related chronic diseases, or you just look at the economic side of things, again, either way, it's bad. So the question that we'll address kind of later on here is how do we turn things around, right? Because as a nation, we have to reverse these current trends. Because if the current situation persists, children today will live shorter and less healthful lives than their parents as a result of this obesity and chronic disease and type 2 diabetes epidemic. In addition, right, the country will go bankrupt. I mean, this is a lot of money that we're talking about that's being spent on these different diseases and conditions. So I think we can all agree that the medical community's current approach for weight loss and just treating these chronic diseases is clearly not working, despite billions of dollars spent each year on research and advertising. Right, just an example, members of the public are drowned each year or every day with unhelpful messages about maintaining a so-called healthy weight through calorie counting, and many still wrongly believe that obesity is entirely due to a lack of exercise. Right, it's for these reasons that I'm going to present to you over the course of this presentation what I think, the real problems of the obesity and type 2 and other chronic disease epidemics are, and then also present with you again the real solutions. So here's some data depicting trends in adult overweight, obesity, and extreme obesity among men and women aged 20 to 74 in the United States from 1960 to 2012. So it's neat to look at this data because this shows you data, again, regarding overweight and obesity going back 6-7 decades ago. So if you look, say, at obesity rates in the 1960s, you can see about, for males and females, it was somewhere around 10-15%. So it's not like there was zero people who were obese, in say in the 1960s or 70s. It's just that there wasn't an obesity epidemic, right? Today we have an obesity epidemic where close to 40% of adults are overweight or obese. Back then it was much less, close to, like I said earlier, more like 10-15%. However, again, if you look at this graph, it would appear that there was a very slow, gradual increase from 1960 to 1980. But then something happened there in 1980 because you can see a very steep, exponential, very drastic increase in male and female obesity rates here in 1980. That's why I have a little arrow right there pointing to that specific time period, right? Because, you should be interested in what happened here. Did our human genome change? And so overnight, we just became more susceptible to becoming overweight or obese or gaining weight? No, that would be ridiculous. But so something else had to change. Probably something in our environment had to change that caused this pretty drastic rise in the percentage of people who are obese. And if you remember earlier, what happened during that particular time frame? Right? Remember, the first dietary guidelines for Americans came out in 1980. Something to think about. Here is a more recent article depicting the trends and prevalence of obesity among US adults 20 years or older from 2007 to 2016. And what I did here is I highlighted kind of just the overall obesity prevalence over the course of the last couple of years. So if you look at the obesity prevalence from 2007 to 2008, it's about 34%. And if you look all the way over to the right, 2015-2016 data, the obesity prevalence, is basically close to 40%. So even just over the course over the last 10 to 15 years, I mean, there has been a pretty dramatic and continual increase in the obesity epidemic. So this figure shows you the projected rates of obesity by 2030, meaning if the current trends continue, it would appear by the year 2030, which is not that far from now, only about 10 years or so, the overall obesity prevalence in the United States will be just over 45%, heading upwards towards 50%. So we just looked at the current obesity prevalence and statistics, and it looks really bleak. But if you look at the future projections, it looks even worse. So earlier on, when we were looking at the health by the numbers, one of the most striking and alarming statistics is that currently in the United States, just over 50% of adults are either pre-diabetic or diabetic. And here's the article, so you can see for yourself where this statistic comes from. So here's a fairly recent article published in the Journal of the American Medical Association entitled Prevalence and Trends in Diabetes Among Adults in the United States from 1988 to 2012. So if you just look at the overall prevalence, so for those who have been diagnosed with diabetes, the overall prevalence is about 14%. However, then you add that with those who are pre-diabetic. So the pre-diabetic prevalence is 38%. So if you add that together, I mean, you end up with just about 50%, or just above 50% actually, of the adult population in the United States either being pre-diabetic or diabetic. So this is really important. So I just want to let that sink in for a little bit, because that's a large number of people. And I'm going to argue that that number is probably a little bit higher. Because if you look, and you can see this in this table from this article, how did they measure this, or how do they define diabetes or pre-diabetes? What cut points do they use according to what measurements? They used HbA1c, so glycated hemoglobin, or plasma glucose, or 2-hour plasma glucose levels. But really and those are all great measurements, especially HbA1c, but really the gold standard is fasting insulin. So if you were to measure somebody's fasting insulin levels, or you do what's known as the Kraft 5-hour insulin test, however they shorten it up to a 2-hour insulin response, so you ingest about 75 to 100 grams of glucose, and then you measure, say every 30 minutes, you measure the insulin response to that glucose. And that is really kind of the gold standard test to see if you are diabetic, or you have kind of diabetes insito, kind of diabetes in development. And you can go look at some of the work from Joseph Kraft, what he did in a large sample of people, not necessarily representative of the population, but a large sample of people, and I think like 15, 16,000 people, and the vast majority of them actually failed that test and had kind of diabetes in development. So if that test was used, some type of insulin response, fasting insulin, or insulin response to glucose, I think this number would be higher. So it's actually not good news, it's actually bad news or even worse news. Because this 50% number would probably be, I mean, I'm guessing now, but based on the work from Joseph Kraft, it could be 5, 10, 15% higher. And so that is a humongous, if not the most biggest factor or problem that we are facing. The fact that we have the majority, right, the majority of people in the US, but also globally, pre-diabetic or diabetic, meaning they are what's known as insulin resistant. Okay, they are insulin resistant. So remember that, because we're going to talk about that later, and how the fact that the majority of the population is insulin resistant, how that then ties to this chronic disease epidemic, and how that then in turn ties to what the current dietary guidelines should be, or what foods or diets we should be eating based upon the current health crisis, based upon, again, the current situation, the fact that more people are insulin resistant than those who are not. So here's a figure showing you the overall prevalence of diabetes over the course of the last couple of decades. So if you go back a couple of decades ago to the 50s, 60s, or 70s, the overall prevalence of diabetes, especially type 2 diabetes, was pretty low. And that's true for not just diabetes, but for most other chronic diseases. What I mean is, the further you go back in human history, the less prevalent that specific chronic disease was. However, today we have a chronic disease epidemic, whether it's type 2 diabetes or obesity or heart disease or cancer, etc., etc., etc. And that's just always something to think about, right? You know, you go back, the further you go back in human history, all these conditions were not prevalent, and today they are very much prevalent. So they are diseases, therefore, of lifestyle. However, you know, as we said earlier, I think most of these diseases really stem from our habitual macronutrient or just dietary intake. So if you take a look at this figure, you see clearly that the US diabetes epidemic began here in kind of the mid-1990s. That's kind of where you see this exponential increase in the overall prevalence of diabetes. So you should therefore ask yourself, you know, what caused, because something, right, something in the environment had to change that causes this exponential increase in the overall diabetes prevalence rates. So therefore you have to go back and see what preceded that. Well, as we saw earlier, the obesity epidemic began here in the 1980s. What happened also right about there at the same time, you had the first introduction or the inception of the dietary guidelines, right? So the dietary guidelines were introduced here 1977, 1980 period, soon after the obesity epidemic began. And then 20 years later, we have the diabetes epidemic that began. So that's really interesting. And there's biological plausibility for that, meaning there's research that shows that, you know, if you have this kind of 20-year rule showing that if you take a population and you change their diet, it takes about 20 years for diabetes or type 2 diabetes to start. Because type 2 diabetes, like many other chronic diseases, doesn't happen overnight. It happens over the course of years or decades. And it's really, you know, type 2 diabetes is really a dietary disease. And we'll look a little bit more here next at the pathophysiology and mechanisms of type 2 diabetes. But it's really a dietary disease. So is it any surprise that we changed the way that we used to eat, right? Because if you look, you know, at some of the papers, the data that I showed you here in the 50s, 60s, you know, people were eating actually more fat compared to carbohydrate, but then we vilified fat and we introduced everybody to lipophobia, right, the fear of fat, and right, and then people listened because we saw, you look at the compliance data, people listened. The American public listened, and they stayed away from fat or started eating less fat, and they started to eat more carbohydrate. So very good evidence that that on average, people changed the way they used to eat, started eating more higher carbohydrate type diets. And so it's interesting that that happened, and 20 years later, the diabetes epidemic began. So I think the damage was really caused by the adoption of the 1977 USDA dietary guidelines. And the effects of that really didn't take long to surface. I mean, you can see the obesity epidemic began soon afterwards, and 2 decades later, you have the diabetes epidemic began. And this is kind of rather predictable, since carbohydrates are not satiating. They drive hunger. And because it's true that people are eating a couple of hundred more calories today more than what they were, say, a couple of decades ago. But it's also true that where's those calories coming from? Those additional calories that we're consuming now compared to a couple decades ago, it's coming from carbohydrate. Almost exclusively, the additional calories that we are consuming now compared to a couple of decades ago is coming from carbohydrates. And carbohydrates is the least satiating macronutrient. Fat is saturating, protein is probably the most saturating macronutrient, but not carbohydrates. So it drives hunger, and so therefore you overeat. So it's not so much about the calories, it's about the quality, right? It's where the calories are coming from. And so really, once you start doing some research and you dig into this a little bit more, it's not a surprise that we have a type 2 diabetes epidemic if you understand what happened or what kind of preceded it with the changes in the dietary guidelines and people eating more of these high carbohydrate diets over the course of the last couple of decades. So a really important question is this coincidence or cause? Really, because since the late 1970s, the US government and also much of academia has consistently recommended lowering the dietary percentage of fat, especially saturated fat, as well as absolute levels of dietary cholesterol, and to start eating more carbohydrate. I think most of you have seen the food pyramid, right? And at the base of the food pyramid, you have the foods that you are supposed to eat more of. Those are supposed to make you lean and healthy. So you have the bread, the cereal, the rice, the pasta. Above that, you have the fruits and vegetables. And there at the top, you have the animal products, or the products that contain more fat and more saturated fat. Meaning, again, those items at the top, stay away from them, or eat little of them. Because if you eat too much of them, that's going to negatively impact your health, right? You'll gain weight, and you'll get heart disease, cardiovascular disease, etc. And those items at the bottom, you can eat a lot of those because they are healthy and they'll make you, lean and skinny, and reduce the risk of chronic disease. So, coincidence or cause? The fact that we have clearly seen over the course of the last couple of minutes that since the introduction of these guidelines, people have been compliant, people really have adhered. We have adhered to the dietary guidelines. But instead of making us lean and skinny and healthy, it's almost like the exact opposite has happened. Right? So we have decreased our fat consumption, our cholesterol intake, or saturated fat intake. So, however, again, our compliance has been accompanied by a very rapid increase in obesity rates and type 2 diabetes and also other chronic diseases. So, is this just pure coincidence, or is this causal? That's a really interesting question. I think we should talk more about that. Again, it's the fact that we changed the way we used to eat, and these high carbohydrate diets that most people have been introduced to over the course of the last couple of decades, did that cause the chronic disease epidemic that we are facing at the moment? So here's an article by Cohen and colleagues, and I showed you this article earlier. And this was a statistical review of U.S. macronutrient consumption data, and from 1965 to 2011. And this provides us some insights behind this question of coincidence or cause. They concluded by saying this study demonstrated that general adherence to government dietary recommendations to decrease fat share of total dietary intake has been accompanied by a rapid rise in obesity rates, and the results from the study compel a full analysis of the potential causal relationship between Americans' seeming adherence to the government's nutrition recommendations and obesity. Again, we've complied to the dietary guidelines. It's just that it seems that our compliance have come at a great cost. So you might be sitting there right now going, you know what, this can't be true. This cannot be true. The dietary guidelines has to be evidence-based. When they came out with the dietary guidelines, or the first dietary guidelines in 1980 and kind of the revisions every 5 years thereafter, there has to be good evidence for the diet that they are recommending or for their specific cut points in terms of how much calories you should be consuming from carbohydrate, protein, and fat, especially from their dietary fat recommendation. Right, because the fat recommendation is to consume less than 30% of total calories from fat. So where did that come from? So is there any evidence for the dietary guidelines? That is probably one of the most important questions we should be asking, because so many people are affected, either, as we said, directly or indirectly by the dietary guidelines. And thank goodness there's an article on this, and this was by Zoe. This article was published a couple of years ago by Zoe Harcombe in Colleagues, entitled "Evidence for Randomized Controlled Trials Did Not Support the Introduction of Dietary Fat Guidelines in 1977 and 1983, Systemic Review and Meta-Analysis." So basically, I mean, in light of the current health crisis, the dietary guidelines, I mean, it has come under really considerable scrutiny over the course of the last couple of years. And this review and meta-analysis examined randomized control trials. Remember, so randomized control trials is the best type of evidence there is. When you're doing research, you can do all kinds of different designs. And unfortunately, a lot of the designs in nutrition research is epidemiology or kind of these observational type of studies with pretty weak associations. But again, it's all associational, right? And what we typically teach our students, right, association doesn't equal causation. And so, however, again, a lot of the dietary recommendations do unfortunately stem from that type of science. But the best type of science that we should be looking at, that we should be basing recommendations on, is randomized control trials. Okay, so they just looked at randomized control trial evidence, and they looked specifically at RCT evidence available to the dietary committees to support their dietary fat recommendations, meaning to consume less than 30% of total calories from fat. And the study found that the RCT evidence did not support the introduction of dietary fat guidelines, and called for the current dietary advice to be revised. The article concluded by saying that, and I quote, "Dietary advice not merely needs review, it should never have been introduced." And that is completely true, because if you don't have sufficient RCT evidence for your recommendation, in this case, the recommendation to consume less than 30% of total calories from fat, then you should not have a recommendation in the first place. So I think that's a very accurate conclusion. I think most people would argue that the dietary guidelines need review. Yes, correct. But why was it introduced in the first place if there was no supportive RCT evidence for that particular recommendation? Because you have to understand, right? That's why I started with the macronutrients, Nutrition 101. There's 3 macronutrients: carbohydrate, protein, and fat. So if you're going to tell somebody, or in this case, the entire population, about 300, 400 million people, to consume less than 30% of your total calories from fat, what do you think is going to happen? Because most people, eat about 15 to 20% of their total calories comes from protein. I mean, that's just, if you look at population data, most people, protein kind of stays stable. It's debatable if that's good or bad. I think it's not good. I think most people will benefit from upping their protein intake to something more 20 to 30%, maybe up to 35%. But it's kind of hard to eat 50% of your calories from protein. So normally what happens, as I said earlier, it's normally between carbohydrate and fat. I mean, if you start to eat less carbs, you start to eat more fat. If you start to eat less fat, you start to eat more carbs. So normally kind of inverse relationship between those two. So if you're telling everybody to restrict their fat intake, what do you think is going to happen? Well, then people are going to start eating more carbohydrates. And that's exactly what happened. So it is now increasingly recognized that the low-fat campaign has been based on little scientific evidence and may have caused some unintended health consequences. So these unintended health consequences were recently illustrated by an enormous prospective study on food intake and health. And this study examined the relationship between macronutrients, so carbohydrate, protein, and fat, and cardiovascular disease and mortality in 135,000 individuals from 18 different countries. The authors found that high carbohydrate intake was associated with higher risk of total mortality, whereas total fat and individual types of fat were related to lower total mortality. Total fat and types of fat were not associated with cardiovascular disease, myocardial infarction, its heart attack, or cardiovascular disease mortality, whereas saturated fat, right, the so-called public enemy number one, had actually an inverse association with stroke. So simply stated, high carbohydrate intake was associated with a significant increase in the risk of death, while fat intake was associated with a decreased risk of death. And one of the lead authors of the study said in a press release that the current focus on promoting low-fat diets ignores the fact that most people's diets are very high in carbohydrates, which seem to be linked to the worst health outcomes. So here's just some more evidence just to illustrate the amount of scrutiny and pressure that the dietary guidelines has come under over the last couple of years. For example, in 2015, Congress appropriated $1 million for review of the dietary guidelines process. So the process that it undergoes to review evidence. And this really happened because of serious concerns by researchers and also nutrition experts alike. And so what happened is the nation's senior scientific body was assigned to review this DGA, or the Dietary Guidelines for Americans, their process, their evidence-based process. And the report from the National Academies of Science, Engineering, and Medicine was published in 2017. And so what did they find? Well, they kind of found what a lot of people expected, and that's that the guidelines are not fully evidence-based, and they do not adhere to basic methodological standards for reviewing scientific evidence. So some of the findings from the report was that the DGA process, it lacks scientific rigor. It's not based on sound science. The process needs to be redesigned. They went on to say that the guidelines process for reviewing the scientific evidence falls short of meeting the best practices for conducting systemic reviews, and advises that methodological approaches and scientific rigor for evaluating the scientific evidence need to be strengthened. So basically, in short, the dietary guidelines, which has been in place over the course of the last 40 years, is far from the gold standard. And this is alarming because, as we have seen earlier, really what we eat has a huge role to play. I would argue the most important role to play in terms of impacting our long-term health. And the fact that the dietary guidelines has been in place over the last 40 years, and the fact that people really have adhered to the dietary guidelines, that is concerning, because they have done very little to improve our overall health. And so you can also argue that not just that they have done little to actually improve our health, but our health has deteriorated as a result of adopting the dietary guidelines. And maybe our health would have been better if there has been no dietary guidelines to begin with, right? Because some would argue that we shouldn't, don't revise the dietary guidelines, just get rid of it. Or maybe there should not have been any dietary guidelines to begin with. So, and then just, finally, I mean, the view that the dietary guidelines are not fully evidence-based has been echoed by, again, numerous other scientific experts. For example, Dr. Fiona Godley, she's the British Medical Journal editor-in-chief. I mean, she has said, and I quote, given the ever-increasing toll of obesity, diabetes, and heart disease, and the failure of existing strategies to make inroads in fighting these diseases, there is an urgent need to provide nutritional advice based on sound science. And I think we can all agree that, based upon the current obesity and type 2 diabetes and other chronic disease epidemic, we are in urgent need for evidence-based scientific advice. So the next revision of the dietary guidelines is supposed to come out in 2020. So we will see what happens in that revision, or what happens in terms of in terms of the evidence that they review for it. Hopefully it's going to be better than the preceding 40 years of evidence or lack of evidence. So I started off this presentation with a very important question, and that question was, what foods or diets should we be eating? So hopefully now you understand the importance to that question and how important that answer is. Because whatever that answer is, that is going to determine our state of wellness or illness. So that's what I want to look at next. What type of diets or foods may be ideal for most people? Not necessarily all people, because that was the problem with the dietary guidelines. It was a one-size-fits-all approach. Everybody needs to eat this way. And we have clearly seen that the answer to this question, what type of diet or foods may be ideal for most people, is not what the dietary guidelines recommend. Not the way it is written now in any case. That is clear. So what I want to do next is to look at the evidence, and so we can get to a better understanding in terms of, again, what type of diets or food may be ideal for most people, what diets is compatible with our human biology. So in order to answer this very important question, we have to consider what we as human beings have been eating for most of human history. And I think it's an important point that gets missed. Because quite frequently we get hung up in terms of, what have we been eating over the course of the last couple of decades, when the question should be, what diets or foods have we been eating for most of human history. The reason why it's important is because, each species can eat only that for which it has been genetically programmed as a consequence of its coevolution with a specific group of foodstuffs within a specific environment. So if you can determine which foodstuffs a particular species co-evolved, then you know the foods for which that species are optimally adapted. Meaning, if you look, say you take an example, say you look at, say, a lion or a zebra, and you go, well, what type of foods have lions kind of co-evolved with over the course of many thousands of years? Well, they're carnivores, so they eat meat, right? And that's the diet that's optimal for them, that they thrive on. If you look at a zebra, well, they're eat grass and twigs, or I don't know, whatever zebras eat. So that's the diet that they have adapted to, and that's optimal for them. And if we were to give the zebra's diet to the lion, or the lion's diet to the zebra, pretty quickly, I think both of them, their health will deteriorate, and they probably will die as a consequence. So you can see what I'm saying here. What about us? So what diet has human beings consumed for most of human history? So this is not an easy question to answer, since we are not able to travel back in time. However, for 99.5% of human history, which represents more than 100,000 generations, we lived as hunter-gatherers. So what did humans eat before the agricultural period? Right, because the agricultural period represents only the last 0.5% of human history. And an article regarding hunter-gatherer diets, which was published in the year 2000 in the American Journal of Clinical Nutrition, provides some answers to this. So this study found that, quote, whenever and wherever it was ecologically possible, hunter-gatherers would have consumed high amounts of animal food. Most hunter-gatherer societies worldwide derived over 50% of their subsistence from animal foods, whereas only about 14% of these societies derive more than half of their subsistence from gathered plant foods. So basically about 2/3 of their total calories came from animal foods and 1/3 came from plants. Also, what this article shows is that modern foods that typically constitute more than 60% of all calories in a typical Western diet, including grains, sugar, flour, candy, etc., would have contributed virtually none of the energy in the typical hunter-gatherer diet. So it could be that we simply did not evolve to eat refined carbohydrates, or at least not in the quantities that we do today. And therefore, it's those types of foods that are damaging or that are fattening and not, say, fat itself. Since our ancestors were indeed eating a diet that was definitely lower in carbohydrate and also higher in protein and higher in fat. Here's just a figure showing you carbohydrate consumption timelines over the course of the last couple of million years. It would appear that as human beings, our carbohydrate intake has been pretty low. However, if you look at this all the way over there to the right, you can see something is going on there, kind of there by the 20th century, right? Because over the course of the last couple of decades, since the inception of the Dietary Guidelines, has our carbohydrate intake increased dramatically. So that's why I like this quote. If we are looking for a dietary cause of some of the ills of civilization, then we should look at the most significant changes in man's diet. So where is the most significant changes in man's diet? Where has it occurred? Well, it has occurred over the course of the last couple of decades. And it has coincided with the chronic disease epidemic that we are facing today. So to further illustrate this point, let's look at the most obese nations on the planet. The most obese populations in the world are all islands in the Pacific. American Samoa, Tokelau, Tonga, etc. So they have not just high rates of obesity, but very high rates of obesity, 50, 60, 70%. So why is this the case? Well, these people have lived for centuries on fish, coconut oil, and very little else, and they've adapted to this diet and were lean and healthy. But as soon as the industrial diet, the sugar, flour, grains arrived, obesity and chronic diseases appeared. So, in short, the foods we are eating today is very different than the foods we co-evolved with. My argument is that people are eating a diet which is very new to human history, this high carbohydrate diet, and which is incompatible with our human biology and what we are designed to eat. Any surprise, we have global epidemics of chronic diseases. So here's one more example that I wanted to share with you in terms of the health of traditional societies, or more specifically, what happens to the health of traditional societies when they stop eating their traditional foods and they start eating the modern industrial diet, which is high in sugar, refined grains, trans fats, and vegetable oils. What normally happens is modern diseases starts to appear. The obesity, the type 2 diabetes, the cancer, and the heart disease. So here's one example, and this is with the Alaskan Inuit. Now, just a little bit background information, and if you want some more information about traditional societies and eating their traditional foods and what was their health like, you can go look at the work that was done more than 70 years ago by a Cleveland dentist named Weston Price, who decided to embark on a mission, and he did a lot of traveling. So he traveled to various isolated parts of the planet where inhabitants had no contact with civilization, to study their health and physical development. And so his investigations took him to isolated Swiss villages, islands off the coast of Scotland. He studied traditional Eskimos, Indian tribes in Canada and the Florida Everglades, South Seas Islanders, Aborigines in Australia, Maoris in New Zealand, Peruvian and Amazonian Indians, and tribesmen in Africa. So definitely, if you're interested in some more of this, you can go look at his work. Okay, but just as an example, because he traveled and he studied also the Alaskan Inuit. I mean, he said they are an example of physical excellence and dental perfection, such as has seldom been excelled by any race in the past or present. He said, noted that they are robust, muscular, and active, and the physical constituent of both sexes is strong. In addition, also a Harvard biologist, Stefansson, wrote a number of books describing the experience of living with the Inuit for many years. And again, he noted the same thing in terms of the health of the Alaskan Inuit back then was very good. Today, that's not the case. The Alaskan Inuits today have very high rates of type 2 diabetes, cancer, heart disease, kind of these diseases, kind of modern day westernized type of diseases that we typically see. So this is interesting because if you just look at what foods or what diet did the traditional Alaskan Inuit eat, or what diet did that consist of? Well, I mean, this comes right here from this paper that has been recently published. They say the traditional Alaskan Inuit diet consisted of less than 10% of total calories as carbohydrate. So the traditional Alaskan Inuit diet was low or very low to almost no carbohydrate. So it was a very high fat diet. So they ate a lot of fish, whale blubber, seal blubber, etc. But again, what happened is they were introduced to the industrial diet that is high in sugar, grains, trans fats, vegetable oils, etc. And or as you can see here from the paper, sugar-sweetened beverages are the main source of calories in the Alaskan natives, with added sugars making up 20% of total calorie intake, compared with 40% of calories consumed in a general population. So high sugar, high carbohydrate diet, that's what they're eating now. But again, they went off their traditional diet, which was very low carb / no carb, and they are eating a diet that's completely different to what they arguably have been consuming for most of their existence. So again, just another example to just kind of to illustrate what happens if you eat a diet that's not compatible with your human biology. So in conclusion, right, it would appear that, again, for most of human history, we were eating diets, most people were eating diets that were, most tribes or civilizations, traditional societies were eating diets more lower in carbohydrate. And only when we began to eat, cereals and grains at the start of the agricultural revolution, and most especially when our kind of ancestral food choices were displaced by kind of more modern day foods that we're used to today, kind of these more higher carbohydrate types of foods, that's when the modern diseases of kind of lifestyle began. The obesity, the type 2 diabetes, the heart disease, the cancers, etc. So again, the key point here is, as I mentioned earlier, these aren't really lifestyle diseases. They are really dietary diseases. All right, so next I want to talk a little bit more about insulin resistance. So remember, we have a chronic disease epidemic, not just in the US, but also globally. So the real question should be, what is the underlying cause behind the chronic disease epidemic, right? Is there a common denominator? And it would appear from the literature that the answer to that is yes. It would appear that insulin resistance is a common denominator, or is the underlying cause behind many of these chronic diseases that we are facing today. So that's why I want to spend some time in the next couple of slides looking at insulin and insulin resistance, because I think once you understand what that is, it brings you to an appropriate conclusion in terms of what foods or diets we should actually be eating, since, as we mentioned earlier, over 50% of the population is pre-diabetic or diabetic, which means they're insulin resistant. Okay, now turn your attention to kind of what you see here on the slide, because really the problems, one of the big problem in medicine is that kind of you see what is above the surface, and we kind of ignore what is beneath the surface. And what you see on top or above the surface are the chronic diseases. It's the hypertension, the obesity, the gout, the type 2 diabetes, the atherogenic dyslipidemia, etc. And we kind of ignore, though, what's below the surface. So the point of this illustration is that these are not really separate diseases. They are all the same disease. They are not really even diseases, or at least not the way that we think about diseases. They are really kind of, they're an abnormal physiological response to an abnormal input. Okay, so they're an abnormal physiological response to an abnormal input. So, for example, instead of saying, well, you're hypertensive or you have high blood pressure, it would be more appropriate to probably say, well, you're insulin resistant. And instead of saying, well, you have type 2 diabetes, you would say, well, you're insulin resistant. So all those things there on top, those are just symptoms. Those are just symptoms. They are symptoms of an underlying condition. And the underlying condition is insulin resistance. Okay? So when you ingest food, especially food that contains mostly carbohydrate, say for example bread, your body breaks down that carbohydrate to glucose. Now you only have 5 grams of glucose in your blood. Again, that's the equivalent to about 2 teaspoons of sugar. So your blood glucose levels are very tightly regulated. So what happens when you ingest a higher carbohydrate meal is that your blood glucose level will go above that 5 gram level. And your body will in turn secrete insulin to lower your blood glucose level to get it back down to normal levels. So the higher the blood glucose, the more insulin will need to be secreted to take care of the glucose. So once insulin is secreted, it will facilitate the transfer of glucose back into your body cells. This is how normal blood glucose regulation works. However, it would appear that not all humans are created with an equal capacity to metabolize carbohydrate. Instead, a sizable proportion of humans are unable to store the glucose derived from ingested carbohydrate normally in their liver and muscles, and have the condition of insulin resistance. Insulin resistance is a very complex condition, but at its root, insulin resistance is basically a form of carbohydrate intolerance. So let me repeat. So if you are pre-diabetic or diabetic, you are insulin resistant. So type 2 diabetes means you're highly insulin resistant. And if you are insulin resistant, you are intolerant to carbohydrate. If you are insulin resistant, you are always over-secreting insulin, which in turn makes you even more insulin resistant. So this is a vicious cycle. And research shows that there are many conditions linked to hyperinsulinemia, i.e. insulin resistance, including the metabolic syndrome, type 2 diabetes, gestational diabetes, obesity, osteoarthritis, certain cancers, breast and colon cancer more specifically, Alzheimer's disease and other dementias, gout, tinnitus, schizophrenia, and autism, just to name a few. In addition, persons with insulin resistance convert excess ingested carbohydrate into triglycerides, which is fat in the blood. So if you have insulin resistance, you convert excess ingested carbohydrate into triglycerides, specifically in the liver, producing what's known as non-alcoholic fatty liver disease, which is also an epidemic in the United States. Or you export the fat in the blood, raising your blood triglyceride levels. Excess production of hepatic or liver triglyceride reduces your high-density lipoprotein levels, kind of your what's typically referred to as your good cholesterol, and increases the production of small, dense, low-density lipoprotein cholesterol, typically referred to as your bad cholesterol. Persons with an increased number of small, dense LDL cholesterol particles are actually at a threefold greater risk of suffering a heart attack. Small, dense LDL cholesterol particles are more damaging because of an increased susceptibility to oxidation. So, what drives insulin resistance? Well, a high carbohydrate diet consumed over the course of many decades. That's the problem. So one of the key factors to a high carbohydrate diet is that you make yourself more insulin resistant. And so every time you eat more carbohydrates, you become slightly more insulin resistant. So you can think of insulin resistance as a continuum. If you take a look at the figure, you're either highly carbohydrate tolerant, normal, or highly carbohydrate intolerant, meaning you're insulin resistant. So if you're insulin sensitive, for example, like elite athletes, not all elite athletes, but a lot of elite athletes are very skinny, very lean, and they are insulin sensitive. So if you're like that, you can probably eat what you want and it probably won't hurt you in the long term. But again, that's a small segment of the population. If I were to guess, maybe 5 to 10% of the population. Okay, so it's a minority, not the majority. However, if you are to the left of this continuum, there is only one way you are going on a high carbohydrate diet. Increased waistline, obesity, metabolic syndrome, type 2 diabetes, etc. So if you are highly insulin resistant, you cannot consume or you cannot continue to eat and consume a high carbohydrate diet, period. I mean, you're going to have to restrict or limit your carbohydrate intake, meaning if you're, say, highly insulin resistant, you have type 2 diabetes, you have to consume about 25 to 30 grams of carbohydrate per day, and that's it. And if you continue to eat, say, 100 or 200 grams of carbohydrate per day, and you're highly insulin resistant, you are in essence killing yourself. So once you understand this, why would you ever eat a high carbohydrate diet if you're insulin resistant? Or better yet, if you are a healthcare practitioner, a registered dietitian, or a medical doctor, why would you ever prescribe a high carbohydrate diet to someone who is insulin resistant? It's medical malpractice, one could argue. Unfortunately, most individuals who are pre-diabetic or diabetic are still being prescribed and advised to eat high carbohydrate, low-fat diets. So in my own personal opinion, this is one of the main reasons why we have seen explosions of chronic diseases over the last couple of decades. And it is because we are exposing insulin-resistant populations to these high carbohydrate intake and diets. So in the previous slide, I talked a lot about insulin resistance and how insulin resistance is really the underlying cause. It's the root cause of many chronic diseases, or this chronic disease epidemic that we are facing today. So I wanted to show you a review article that just provides some evidence and substantiates that point. So here's a review article that was published not that long ago entitled Hyperinsulinemia, Unifying Theory, right? A unifying theory of chronic disease. So here's conditions linked to hyperinsulinemia. That comes from this paper: metabolic syndrome, type 2 diabetes, obesity, osteoarthritis, certain cancers, Alzheimer's, gout, tinnitus, schizophrenia, autism, etc. So this is basically just medical consequences of insulin resistance. Or to put it another way, of a high carbohydrate diet consumed over the course of many decades, right? Because one of the main reasons why we have seen explosions, because that's what we have seen. We've seen explosions of certain chronic diseases, especially obesity and type 2 diabetes, just over the last 3 or 4 decades. One of the main reasons we've seen explosions of chronic diseases is because we're exposing an insulin-resistant population to high carbohydrate diets. Because it would seem that a lot of people are prone to be insulin resistant, or just are insulin resistant, right? If you go back to the previous slide, we put insulin resistance on that continuum. You say, well, you're either highly insulin sensitive, you're somewhere in the middle, or you're somewhere over to the other side, and you're kind of more carbohydrate intolerant. You're kind of more towards that the other side of that spectrum, where you're more insulin resistant. And it would seem more people do fit towards that side of that spectrum. And the only reason why I'm saying that is because, as we have shown you, as I've shown you earlier in this presentation, it's really evident by the fact that you have over half of the population either pre-diabetic or diabetic, or basically insulin resistant. And I think an important point to make is that insulin resistance by itself is kind of benign. It's only if you are insulin resistant and you keep your carbohydrate content low, then you're probably not experiencing any of those symptoms of the insulin resistance, right? You're not getting the hypertension, you're not getting the type 2 diabetes or the atherogenic dyslipidemia, etc. However, if you are insulin resistant, especially if you're highly insulin resistant, and you keep on eating a high carbohydrate diet, or you are eating a high carbohydrate, that is when you start to experience those symptoms of insulin resistance. So I think it's an important point to make. Insulin resistance by itself is benign. It only seems to be dangerous or starts to negatively impact our health if you continue, or if you are eating a high carbohydrate diet on top of it. And again, most people eat a fairly high carbohydrate diet where 40, 50, 60% or sometimes higher of their calories are coming from carbohydrate, or more specifically just the gram amounts. A lot of people are consuming well above 200 grams of carbohydrate per day. I mean, a lot of people are consuming more close to 300 grams of carbohydrate per day. And again, that's it. If you do that over the course of many decades, and you fall towards the other sides of that insulin resistant spectrum, that's when you experience the medical consequences of insulin resistance. All right, so what I want to talk about next regards the pathophysiology or the etiology of obesity and type 2 diabetes. So two of the most common and the most serious chronic diseases that we are currently facing, right? Because both of them have increased dramatically over the course of the last, say, 3 or 4 decades. And a lot of people are affected by it. I mean, just quick review, right? We said 40% of the population is currently obese, and 70% is either overweight or obese. Type 2 diabetes, over 10% have type 2 diabetes. However, again, just over 50% are pre-diabetic or diabetic. And there's a lot of crossover between these diseases and conditions. For example, if you look at type 2 diabetes, I mean, about 80% of people with type 2 diabetes are overweight or obese. And again, just obesity, I mean, if you look at the literature, obesity is associated with many other chronic diseases. It has many other comorbidities, whether it's, again, like type 2 diabetes or hypertension, or certain types of cancers, or heart disease. You've just kind of fill in the blank. There's normally some type of strong association between excess fat accumulation, i.e. being overweight or obese, and some other chronic disease and condition, right? Because obesity at the root of it, you have chronic inflammation, and you have the insulin resistance, and then you have the associated symptoms as we were talking about earlier. And again, if you look at type 2 diabetes, I mean, very, very, very serious condition. I don't think a lot of people understand the seriousness of the type 2 diabetes epidemic. And because type 2 diabetes, it's such a it's such a terrible disease because it affects so many different organ systems in the body, and that's why you kind of want to do everything in your power to prevent yourself from ever becoming diabetic. For example, if you have type 2 diabetes, it affects the vascular system. So now you have a much increased risk of coronary heart disease leading to a heart attack, cerebrovascular disease leading to a stroke, peripheral arterial disease. It could affect the damage your sight or your vision, your eyes. You can go blind. Can lead to amputation. Affect the kidneys. Affects the nervous system, leading to neuropathy. So I mean, type 2 diabetes is I think the leading cause of adult onset blindness and lower limb amputations, and also end-stage renal failure. So that's why it's such a costly disease, because it's affecting many other organ systems in the body. Okay, so that's kind of where we want to go next. It's just to briefly touch a little bit on the obesity and type 2 diabetes, kind of the etiology of both. And basically, again, both of them have a lot to do with the hormone insulin. So really, it's about the insulin. It's really about the insulin driving the pathophysiology or the etiology of both of these conditions. For example, I mean, if you have a lot of insulin that's being secreted quite frequently throughout the day, I mean, that over the course, if you just multiply that out over the course of days, weeks, months, years, decades, you're going to gain weight, because insulin is a storage hormone. It's a fat cell fertilizer. And that's another debate that people have with with weight, or what causes weight gain. Is it just about the calories? So if I just consume too many calories, doesn't matter where the calories come from. If it's too many calories from carbohydrate, protein, or fat, it's just it's all about that calories in, calories out model. So if my calories in exceed my calories going out, then slowly but surely I'm going to gain weight. However, I think that's a flawed model, because it's just about quantity. I think it neglects the quality. Because if you look at, there's numerous studies that you can look at where people are fed isocaloric diets, meaning the diets that they are given are the exact same number of calories. So people might go high carb, low carb, or kind of a, say, medium carb or Mediterranean style diet, but all groups are, say, giving the exact same number of calories, say 2,000 calories, but where the calories are coming from are completely different. And then they track the people, or that's kind of the intervention for, say, a month or a couple months. And what normally happens at the end of the study is there's a difference. There's a difference in weight. There's a difference in the overall cardiometabolic health of those subjects. So to me, it's nonsense that it's all about calories, and it comes from a flawed understanding that there's differences between proximate and ultimate causes of whatever scenario that you're looking at. And I kind of got that understanding when I read a great book by Jason Fung, and he was talking about proximate and ultimate causes. And in terms of obesity, we got it wrong, because we think it's all about calories. So if there's too much coming in and too little going out, then you're gaining weight. So that's why the model for weight loss over the course of the last couple of decades has been to eat less and move more, because that's the solution according to that model. And there's been very little success, almost no success with that message over the course of the last couple of decades. Because it's wrong. It's wrong. I mean, if it, you know, we've tried it in numerous studies, and not just in studies, but numerous people have tried it, and you know, it works. Not it do, I mean, it doesn't work. Not because of the person and the person's lack of willpower. It doesn't work because the model is wrong. Because calories is the proximate cause. It's not the ultimate cause. The ultimate cause is insulin. Insulin is driving the weight gain. And I mean, you can ask people who are diabetics. So you can ask the diabetics this, especially the diabetics who are taking insulin. They will tell you, I mean, if they're taking insulin, they're gaining weight. And you can go look at studies where people are given different amounts of insulin. So either, say, a regular insulin dosage or a more intensive insulin dosage. And those who are given more insulin gain more weight. And so more insulin, more weight. And you might be sitting there going, well, you know, maybe you're not diabetic, right? Or you're not being prescribed insulin. And you're saying, well, I'm not diabetic, I'm not taking insulin injection, so who cares? Well, even though nobody's injecting you with insulin, most people's lifestyle is sufficient to mimic that same response. Okay? So let me say that again. So even though nobody might be injecting you personally with insulin, most people's lifestyle is sufficient to mimic that same response. And that goes back what I have on the slide here. It goes back to what we were talking about. It's our diet. That's the biggest factor here. So we have 3 macronutrients, remember? Carbohydrate, protein, and fat. Now, as you can imagine, they have a different effect on your glucose and insulin level. Carbohydrates stimulate insulin the most. You know, protein to a lesser degree, and fat has a very little effect on insulin. So of the 3 macronutrients, carbohydrates stimulate insulin the most. So as already outlined previously in this talk, right? Remember, we are eating, most people, not necessarily all people, but a lot of people are eating a high carbohydrate diet where over 50% or close to 50% of their calories come from carbohydrate. But you know, and in terms of grams of carbohydrate, most people are eating up towards 300 grams of carbohydrates or more per day. So that's one problem. But then the other problem is we're eating quite frequently. Most people are eating quite frequently. It's the breakfast and then a snack, and then the lunch and then a snack, and then a dinner and then a snack. So most people are eating, you know, 3 meals per day and then snacking 2 or 3 times as well. And most of those meals and most of those snacks are normally pretty high in carbohydrate. I don't mean fruits and vegetables. I mean refined carbohydrate. A lot of sugar. So therefore, the problem is twofold, right? It's meal composition and meal frequency. So it's meal composition and meal frequency. And when you put both together, right, both will increase your insulin levels, which in turn will drive, you know, not just the weight gain, but also insulin resistance and then the other comorbidities that's associated with it. I mean, think about it. If you follow kind of the standard American diet and the standard American kind of way of eating, if you look at it from a macronutrient perspective and a meal frequency standpoint, and you combine that with the insulin response, what are you going to get? Right? You're going to get a lot of insulin that's going to be secreted quite frequently throughout the day, yeah, with the breakfast, lunch, and dinner, and the snacks in between. And so all you have to do is then multiply that out. Multiply that out day after day, week after week, month after month, right? Year after year. And if you follow that pattern for say a decade or a couple of decades, then you're going to run into trouble, because what you get is you get weight gain, but you also become more insulin resistant slowly but surely. And so slowly but surely you're going to move across that insulin resistant spectrum. So maybe you were okay, but now 2 or 3 decades later, now you're kind of to the one side of that insulin resistant spectrum. So now you're pre-diabetic, and your blood, you can see it from your fasting blood glucose is higher, your glycated hemoglobin is higher, maybe your fasting insulin is higher, right? So now you're pre-diabetic like a lot of people in this country. And if you keep on eating that way, or if you keep on following that pattern, then you'll go from the pre-diabetes to the diabetes. So you can see this has a lot. You know, it's about insulin, and primarily. and it has a lot to do with our diet, and that's why I said, most people's lifestyle is sufficient to mimic that response in terms of, yeah, you might not be, injecting, or somebody's not injecting you with insulin, but a lot of people has that response, and it comes back to our lifestyle. More specifically, it comes back to our diet, and again, the meal composition and the meal frequency. All right, so let's look a little bit more specifically at the etiology of obesity, right? Why do we gain weight? And obviously, this is a very important question, and you can probably also imagine that there's numerous views and theories on it. However, the one that has predominated over the course of the last couple of decades has really been centered on calories, right? It's all about too many calories consumed and too little being expended. So therefore, according to that particular model of obesity and weight gain, the treatment should be to eat less and move more. So, what's the problem with that common sense kind of strategy? Well, the problem is it simply doesn't work. And time again, in numerous randomized controlled trials, that treatment has failed. And one of the best examples to illustrate the tremendous failure is a study that was published in 2006 entitled Low-Fat Dietary Pattern and Weight Change Over 7 Years at the Women's Health Initiative Dietary Modification Trial. And so what they did in that study, they took close to 50,000 women, and they randomized them to two groups. One group was just a control group, so I just gave them a copy of the dietary guidelines and said, "See you later." And then the other group was the intervention group. And the intervention group, they wanted them to eat kind of basically a low-fat diet. So they had a series of education sessions to reduce their total fat intake to about 20% of their daily calories, and also increase their intake of fruits and vegetables, fruits to 5 servings a day, grains to 6 servings a day, and they also encouraged them to exercise more. They ate less. Also, so it's basically a big eat less, move more campaign, and they had so many different group activities and individual interviews, targeted messaging campaigns, personalized feedback, so to make sure that the people in the intervention group followed the advice and nutrition recommendations that were given to them. So, what happened? It's such a huge study, one of the most expensive and biggest studies of its kind ever done. So we should probably all be familiar with the results, because it has, I think, a lot of very important implications. So basically, the intervention group, they started off good. They lost about 4 pounds over the first year. And this study, the other great thing about the study is it was longitudinal in nature. They tracked people for an average for about 7.5 years. So the first year they lost about 4 pounds. But by the second year, the weight started to, come right back again. By the end of the study, there was no significant difference between the two groups. And in addition, the study showed that, reducing calories, or basically eating less, because if you look at the data from that study, they ate less by about 360 calories a day, every day for about 7.5 years, and they increased their activity by about 14%. It did not result in any more weight loss than doing nothing. There was no difference between the intervention group and the control group. So really the conclusion here was that, or the conclusion you can draw from this, that weight loss over this 7.5 year period of eating less and exercising more, because that's exactly what they did. And they it's not just that they ate less and exercised more, they ate less fat and they ate more carbohydrate. Everything according to the dietary guidelines and kind of conventional advice. It didn't even result in like 1 single kilogram being lost. So it was a huge failure, right? And it's published in 2006. Very few people I think are even familiar with that, and because it came out and the results were, it's kind of like a null finding, which by itself is an extremely important finding actually, but it was ignored because it didn't fit the current train of thought. So that's why I said we should move past that kind of caloric-centered view of weight gain and obesity, and look at some other your models and strategies. For example, what I have here on the slide, we can call this the fat cell theory of obesity. And it has a lot to do with insulin, as we mentioned on the previous slide. And again, if you have a large amount of insulin being secreted quite frequently over a period of time, that's going to cause adipose tissue dysregulation. So that hyperinsulinemia triggers the fat cells to grow. And they get, you get adipose tissue, hypertrophy, hyperplasia, increase the size, number of N. Why? Because of insulin. And over time, because you have this adipose tissue dysregulation, that's then going to cause decreased calories basically in the circulation, because it's basically the adipose tissue is starting to hoard all the energy. So the energy coming in is going to the adipose tissue, and so that leaves fewer calories available in the circulation. And the first organ to pick that up really is the brain. So the brain's going, hey, where's my energy? Because really the brain is an energy hawk. It uses a significant amount of calories on a daily basis, and so therefore the brain goes, sets off some emergency alarm signals, and it can obviously increase hunger and food cravings, or decrease your metabolism, cause fatigue, to kind of solve that immediate crisis. And then you have the outcomes of this, which is the increased energy intake, the decreased energy expenditure. And however, right, normally we have this the opposite way around. Normally we have the increased energy intake and the decreased energy expenditure over there to the left, and we say, well, this is the cause of the obesity epidemic, because people are sloth and and gluttonous. They have you're lazy and you like to eat, and that's what causes the increased energy intake and the decreased energy expenditure, right? But no, I mean, those are, as you can see here from this, these are the outcomes. Those are the results of everything that preceded it. So really, it's the biochemistry comes first, and then the behaviors that we typically associate with obesity, the gluttony and the slothfulness, I mean, those are secondary, right? And I mean, it really, again, insulin's a big player here, causing the adipose tissue dysregulation. Enzymes are involved too, like LPL, HSL, lipoprotein lipase, hormone-sensitive lipase. Lipoprotein lipase is a enzyme that sits on a luminal surface of cells, whether it's or tissues, whether it's adipose tissue or muscle tissue, and hormone-sensitive lipase sits on the inside. And so when you're eating food, or the fat is taken in, digested, and absorbed, that triglyceride needs to be stored, say in the tissue, and the LPL, its job is to break it down into its components, into the free fatty acids and the glycerol, and the free fatty acids can then enter in, because the triglyceride molecule is too big to cross through the cell membrane, so it has to be broken down, and that's LPL's job. And now the free fatty acid can be stored there, say within adipose tissue for later use. And then hormone-sensitive lipase is on the inside, and it just kind of does the opposite. It's responsible for kind of the hydrolysis, or the breakdown of the triglyceride molecule, say inside the adipose tissue, into its components, the free fatty acid and the glycerol, so it can move out and say actually be used for fuel, and be oxidized for fuel, right? Because when you're eating, that energy is then stored, but obviously during the periods when you are not eating, you need energy, and that's when that process is then going to occur. And insulin, has a role on those two as well. I mean, insulin has a tendency to upregulate LPL activity and downregulate HSL activity. So you can imagine if you have a upregulation of LPL activity. So now more fat is being brought in, or more free fatty acids is being brought into the adipose tissue, and now you have a suppression of or inhibition of HSL activity. Well, that then is going to result in less fat kind of exiting the adipose tissue. And that's why we say, insulin is a very strong inhibitor of lipolysis for those reasons. And again, over time, that's just a brief overview or simplistic overview of this kind of adipose tissue dysregulation. And again, over time, how that can then cause kind of this hoarding of the calories. So the adipose tissue is hoarding the calories. And then the problem with that is then the other cells in your body is going, the other tissues in your body is going, hey, what about me? Where's my energy? Well, all the energy is going to the fat tissue, and so now there's little energy going to the other tissue. So it's really a problem of too many calories in the body, but too few in the right place, right? So insulin has programmed the fat cells to grow, kind of into calorie storing overdrive. And people then chronically overeat because they're trying to keep calories in the circulation to feed the body cells, especially the brain, until the underlying problem is addressed. It's really a never-ending battle. And we think of obesity as a condition of excess. It's actually a matter of starvation of the body. So it's another way to think of it. But that's kind of a brief overview of it. And we can see, again, insulin has a lot to do with it. And then we see the outcomes that we typically associate with obesity: the increased energy intake, right? The gluttony and the decreased energy expenditure, the slothfulness. Those are the results. They are not the causes. And the causes is insulin. But then you can also say, well, what caused the insulin to go up? And now, again, there's many different factors that can cause insulin to increase. But obviously a huge one is, from a dietary perspective, is carbohydrate. More specifically, I'm not really talking about fruits and vegetables over here. I'm talking about processed carbohydrates. All the sugar, flour, grain-based products a lot of people are consuming. That's part of their staple diet. Is kind of the initiator in this case. All right, so next, looking very briefly at the pathophysiology or the etiology of type 2 diabetes, or basically insulin resistance. And again, this gets very complex, and I'm just going to try to make it simple, easy to understand. So if you just look at the normal regulation of glucose, right, say you eat some high-carb meal, that gets broken down to glucose, so now you have an increase in your blood glucose. So then insulin is secreted from the pancreas, and it helps to lower your blood glucose, pushes it back into, say, your muscle cells or, say, fat cells, right? Because you can have a high concentration of glucose in your circulation that's toxic, so your body does a good job at getting it back, getting your blood glucose back to normal levels by basically shuttling the glucose into the tissue cells. Okay, and basically, and it's not like insulin goes and attaches to glucose and then drags it into the cell. Insulin is a non-steroidal hormone, so it attaches to receptors on the cell membrane. That's how non-steroidal hormones work. It attaches to specific receptors. So each hormone has a specific receptor, so it attaches to its specific receptor on the cell membrane, and then non-steroidal hormones work through second messenger systems to carry out its hormonal effect within the cell. So insulin attaches to its receptor, and then basically what happens, through a series of complex mechanisms, it activates this little what's known as a GLUT4 transporter. And it causes this GLUT4 transporter that's inside the cell to translocate, meaning to move up to the surface of the cell membrane. And once that GLUT4 transporter vesicle is now moved up to the cell membrane, that's how then glucose is taken up into the cell, and then that's going to continue to happen once your blood continue to happen until your blood glucose has returned to normal, and then insulin production from the liver is then stopped. Sorry, from the pancreas is then stopped, and so that's normal blood glucose regulation. So what happens with type 2 diabetes or insulin resistance, right? And really what happens here is downregulation of the insulin receptors. So when you have this is just kind of endocrinology 101. I mean, if you have a large volume of a specific hormone over a long period of time, what can happen is downregulation. So the receptors for that hormone, they start to decrease in number, and therefore they start to lose their sensitivity for that specific hormone, in this case insulin. And so that's a problem, especially in this case. So so imagine now, again, you have a large volume of, in this case, insulin. So insulin is being secreted from the pancreas, say quite frequently and in large amounts on a regular basis, right, over a extended period of time, right, decades. What's going to happen is those receptors, right? One way to think about it, those receptors for insulin, they go, yeah, I'm sick and tired of you hanging out here the whole time and being secreted the whole time, and then they downregulate, they decrease in number. But as a result, then they would lose their sensitivity for the hormone insulin. But the problem is now there's fewer receptors for the hormone insulin to bind to, right? And now you're on that pathway of insulin resistance, because say now you have that same carbohydrate rich meal, and now insulin is secreted to lower the glucose, but now there's fewer insulin receptors available for it, which means there's going to be less of that GLUT4 activation, because that's what you need, right? It's an insulin-dependent pathway, right? I mean, insulin has to attach to the receptor for that GLUT4 vesicle to move up to the surface of the cell for glucose to be lowered. So if you have a defect in that signaling off to the GLUT4, well then you're going to have diminished glucose uptake, which means what? Which means your blood glucose is going to remain high. Right, that's what happens if you're a pre-diabetic, or obviously if you're diabetic. If you're pre-diabetic, now your blood glucose is going to go from normal levels and it's going to start to tick up. Now your blood glucose is somewhere between, your fasting blood glucose is somewhere between 100 and 126 125 milligrams per deciliter. Right, or your HbA1c starts to go up somewhere between like 5.7 and 6.4%, right? Or like we said, right? So that's kind of what is going to happen initially, and if left untreated, or if you're unaware of that problem, right, then you're going to go from the pre-diabetic state to the diabetic state, right? Because you're hyperglycemic, so your blood glucose is not being regulated. Why? Because you're insulin resistant. Right? And hopefully what I just said, the kind of the mechanisms that I just described, hopefully that makes sense, right? This whole process of downregulation of the insulin receptors, and if you have fewer insulin receptors, how that then is going to result to less uptake of glucose, and then over time, how that is then going to result in your blood glucose kind of starting to increase starting to increase more and more over time. But also what happens is then you have your body tries to compensate for the insulin resistance, and it does so by over secreting insulin. So now your body's, if you're insulin resistant, you're always over secreting insulin. You have this hyperinsulinemic effect. And the problem with that, well, just more insulin is driving the insulin resistance. So it's really a vicious cycle. Right, and then eventually, I mean, you have insulin resistance, and then you have some type of relative insulin deficiency with kind of the beta cells kind of getting burnt out from the pancreas, and the person is put on insulin to kind of, the insulin is the purpose of prescribing a person with type 2 diabetes insulin is to regulate their blood sugars. It's supposed to push all that glucose, right, that's in the circulation, force it into the cells, and it seems like a great idea, but again, you're treating a symptom. You're treating the symptom, in this case is the hyperglycemia, the high blood glucose, but again, that you're giving more insulin and that's going to just keep on reinforcing the insulin resistance, and that was kind of the problem to begin with. So how is giving more a good idea? I mean, it's not just in my opinion, but a lot of other people's opinion. It's that's why it doesn't cure the type 2 diabetes, right? If you use that model in terms of giving more medications, giving more insulin for those who are type 2 diabetic, that's why that's never ever going to reverse or cure that person's condition. That's why we see type 2 diabetes as a lot of people see type 2 diabetes as a progressive, incurable condition, and once you're diagnosed, that's kind of it for you, and you get the medication, and your condition will just kind of get worse over time, and eventually you'll get the heart attack or the stroke or the amputation, or you'll go blind, or some other horrible thing, right? Because it's really the treatment. The treatment is wrong, and it just makes things worse over time. And so, here next we'll get into the solutions, right? Because the problem with this, with the insulin resistance or the type 2 diabetes, and also the obesity, I think you can see it's insulin. It's too much insulin. Insulin is being secreted in large amounts, also quite frequently over a long period of time, and that's the problem. And you can see again how can a person's diet play a role in this, and hopefully light bulbs are going off in your head in terms of all the stuff we talked about earlier, in terms of the fact. How we here kind of the late 1970s, early 1980s, we drastically changed the way that we used to eat. People, most people, are not used to these inordinate amount of carbohydrates, and now we have been eating these high carbohydrate diets over the course of the last couple of decades, and we also, as we said earlier, eat quite frequently throughout the day, and you put that together, you get a recipe for disaster. And to me, in any case, once you understand that, it's no surprise that we have this epidemic of obesity and type 2 diabetes. All right, so next I want to finish off by talking about the solution. The solution to this chronic disease epidemic that we're facing, specifically obesity and type 2 diabetes, and the underlying problem really of both, which is the insulin resistance. And as we just got done talking about, really the instigator, the big problem is insulin, right? Too much insulin, right? And we just got talking about, at least from a dietary perspective, how or different factors that can increase your insulin levels, right? The meal composition, or the meal frequency, and the macronutrient composition, right? Eating frequently throughout the day, and having most of those meals and snacks being high in carbohydrate, especially processed carbohydrate, and the effects that it's going to have on insulin, etc., etc. So having high insulin is not favorable. So therefore, what's the solution, right? I think you could have, if you were listening to what I was saying earlier in this presentation, and you go, well, the problem is too much insulin, too much secretion of insulin too frequently throughout the day. Well, then you go, well, the solution is pretty obvious. It's to lower my insulin levels, especially given the fact that most people in this country are insulin resistant. So therefore, the obvious solution is to decrease insulin. And there's a couple different ways, right? You can decrease your insulin. That's why exercise is important, especially high-intensity exercise. But I specifically want to talk about low-carbohydrate diets. And right, because another one is also, not eating so frequently, like some type of practicing some type of intermittent fasting routine. So, and again, those are all great. Practicing some intermittent fasting routine, meaning instead of eating, say, 6 times per day, I'll cut that down to 3 times per day or 2 times per day, or maybe just eating once per day. There's all kinds of different intermittent protocols or time restricting feeding protocols that you can look into, right? Because not eating, for a certain amount of time has been shown to be beneficial. And you got to be careful though, because there's a difference between intermittent fasting and extended fasting. I'm not a big fan of extended fasting, but doing some form of intermittent fasting, I think will, or definitely according to the literature, is going to be beneficial as well, because you either exist in a fed state or a fasted state, right? So obviously, if you're not eating anything at all, well, that's going to lower insulin, and obviously lowering insulin to a degree is going to trigger fat oxidation, right? It's going to enhance fat oxidation. But the one that I want to talk about next is low carbohydrate diets, right? Because think about that, eating a high carbohydrate diet, has the biggest effect on insulin. So eating a low carbohydrate, high fat diet, is going to have lesser of an effect on insulin, because carbohydrate raises insulin, the most, and fat raises insulin the least. So let's talk about that next. So low carbohydrate diets in terms of its efficacy. So let's look at the science, because there's definitely biological plausibility of why it should work, but you always have to go look at the science and look at the literature. Are the studies there to support its effect on for weight loss or just health in general? So before we get to the scientific literature as it pertains to low carbohydrate, high fat diets, I wanted to first show you this article published in the Journal of the American Medical Association all the way back in 1957. So treating overweight patients. Why do I want to show you this? I want to show you this because a lot of times when people hear or talk about low carb diets, they think it's new, or they think it's a fad, and they think the science is not there. So I think it's not an evidence-based type of diet. Obviously, we'll explore that next. But the other myth is that low carbohydrate diets, it's a fad diet, it's new, because you get a lot of fad diets, one comes around, about every month or so, and then, maybe a celebrity promotes it, and then it kind of just goes away. Well, how can this be a fad diet if this was published in American American Journal of the American Medical Association all the way back in 1957? This was the standard way of treating overweight or obesity. I mean, you can find it. I mean, they talk about it in this article. They say in this article that the usual low-calorie diet is rarely successful. Is readily understood in the light of our present knowledge on carbohydrate and fat metabolism. A low-calorie and low-fat diet is usually unsuccessful due to the ease with which the carbohydrate present is converted into fat. Wow, I mean, they knew this in 1957. They went on by saying that a higher protein, high-fat, low-carbohydrate diet is the one who will produce the most rapid loss of weight without hunger, weakness, lethargy, etc., etc., etc. So I think we can dispel this idea that low carbohydrate diets are fad diets, and for two reasons, right? Because we saw that for most of human history, people were eating more of a lower carbohydrate diet, that's kind of what we talked about earlier. When we looked at kind of traditional hunter-gatherer diets or diets of traditional societies, were fairly low in carbohydrate. And two, well, just in more kind of modern day times, before the whole low-fat era, which kind of started off with Ansel Keys, and you can go learn more about Ansel Keys and the research that he did. That kind of here in the 50s and 60s, and then that obviously had a big role to play in the dietary guidelines that started here in the late 1970s. So since then, right, that kind of introduced the world to lipophobia, and then it changed the way that we think about food and the way that we treat, say obesity and other chronic diseases. But before then, in very prestigious medical journals and stuff like this was being published, or this is kind of the conventional way that a lot of people were treating obesity with low carbohydrate diets. So next, let's get into the scientific evidence regarding low carbohydrate, high fat diets. As we just said, another myth with low carb diets is that there's not enough scientific evidence regarding the efficacy of low carb diets. Well, I'm going to start off by showing you a couple of meta-analyses, and then I'll show you a couple of very well-controlled, well-designed randomized control trials. However, so again, we'll start off with the meta-analyses first. If you're unaware with what a meta-analysis is, meta-analyses, it's a kind of a quantitative way to analyze data from numerous other randomized control trials, right? Because we said earlier, I mentioned randomized control trials is the best type of evidence, and however, what these meta-analyses do is they take all those meta-analyses together. They kind of clump it together and then kind of analyze the data from all those randomized controlled trials. So a lot of times people consider meta-analyses kind of the gold standard because they're looking at all the evidence from the randomized controlled trials. Because it's it's good to look at those RCTs, but you should probably look at not just one RCTs, but the totality of the evidence of those RCTs should be taken into account. And so, if you have a meta-analysis on any type of topic, that must mean that there has been a lot of studies on that topic, right? I mean, you can do a meta-analysis of when you have like one or two studies on that topic. So the fact that there's been numerous meta-analyses on low-carb diets or meta-analyses comparing low-carb diets to low-fat diets, that should tell you something. That should tell you that, there's a lot of research that has been conducted over the last couple of decades regarding low-carb diets. Okay, so here's a systemic review and meta-analysis of clinical trials of the effects of low carbohydrate diets on cardiovascular disease risk factors, and this was published by Santos and colleagues. And basically, all these studies that I'm going to show you, it's published in very prestigious journals. And I'm just going to go through, so you just can see the conclusion of each one of these studies. You're welcome to go on Google Scholar or some other database, download the study and read the study for yourself. That's why I included the study with the title and the authors, so you can go find it yourself. So basically, the results from this first meta-analysis, and this first meta-analysis that you see on the slide, this just looked at low carbohydrate diets. So they didn't compare low carb to low fat diets. This just looked at the efficacy basically of low carbohydrate diets. And the conclusion was that low carbohydrate diet was shown to have favorable effects on body weight and major cardiovascular disease risk factors. So interesting, because now we can see from a meta-analysis that it had favorable effects on body weight, because some people believe, right, if you eat more fat, that it will make you more fat, because a low-carb diet is a high-fat diet, so it actually result in favorable effects on body weight. But then the other thing is with cardiovascular risk, right? That's normally a serious concern too. If I eat all that fat, it's going to clog up my my arteries, and I'm going to get a heart attack or a stroke. But again, the conclusion here was not just the weight; it had a very favorable effect on major cardiovascular disease risk factors. So here's another meta-analysis by Heshin and colleagues entitled Systemic Review of Randomized Controlled Trials of Low Carbohydrate versus Low-Fat, Low-Calorie Diets in the Management of Obesity and its Comorbidity. So this meta-analysis compared RCTs of low-carb diets versus low-fat diets. So this should be interesting because, again, these are two diets, two very popular diets. And again, obviously the low-fat diet we've been promoting very strongly, of course, the last couple of decades. And a low-carb diet is basically the exact opposite of a low-fat diet. So conclusion from this review and meta-analysis was that they said evidence from this systemic review demonstrates that low carbohydrate / high protein diets are more effective at 6 months and are as effective, if not more, as low-fat diets in reducing weight and cardiovascular disease risk up to 1 year. So now that we have a meta-analysis here showing low carbohydrate diets are probably more effective or as effective, if not more effective, compared to low-fat diets. Now, again, not just for the weight, but also for the cardiovascular disease risk factors. Next meta-analysis was by Bueno and colleagues entitled Very Low Carbohydrate Ketogenic Diets versus Low Fat Diets for Long-Term Weight Loss, a meta-analysis of randomized controlled trials. So this looks specifically at kind of the ketogenic diet because, again, there's all kinds of low-carb diets. Normally, typically, people define as low-carb diets when it's less than 130 grams per day of carbohydrate. However, then you get kind of the ketogenic diet, which is a very low carbohydrate diet, and that's typically defined as a diet with no more than 50 grams of carbohydrate per day, because the reason why it's called a ketogenic diet is because then you have that kind of optimizes fat oxidation and a kind of a byproduct of fat oxidation as these ketone bodies in the liver. So that's what they looked at here, specifically just RCTs that dealt with ketogenic diets compared to your standard low-fat diets. And most low-fat diets, in these RCTs are typically defined as less than 30% of energy coming from dietary fat, which makes it obviously, if that's the recommendation, that in turn makes it a high carb diet. Any case, so conclusion here from this meta-analysis was they said the present meta-analysis demonstrates that individuals assigned to a very low carbohydrate diet achieve significantly greater long-term reductions in body weight, diastolic blood pressure, and triglycerides, as well as a greater LDL and HDL increases when compared with individuals assigned to a low-fat diet. So again, greater effect on body weight, and so more weight loss, but also again these other things that they're mentioning are cardiovascular disease risk factors. And it's if you go through the individual RCTs or these meta-analyses, there's normally a theme that will start to emerge. And the theme is that normally the low-carb diet, especially diets that are very low carb, or normally the lower the carbohydrate content, the greater the weight loss. They outperform in almost every single study the low-fat diet for weight loss. So that's one theme. And then the other theme is what happens with these cardiovascular disease risk factors, things like blood pressure, systolic blood pressure, diastolic blood pressure, the different lipids and lipoproteins, so looking at blood cholesterol concentrations, triglyceride concentrations, looking at HDL, LDL, looking at other biomarkers as well. Some of these studies use nuclear magnetic resonance imaging to look at the actual particle sizes. So they look at the different LDL particle sizes. So they look at these the small dense LDL particles and the more larger, more buoyant LDL particles, kind of what's known as this pattern A and pattern B LDL. They look at markers of inflammation like C-reactive protein. They look at blood glucose or glycated hemoglobin, insulin. So there's all kinds of markers, and obviously depending on the study, what they're doing, what their outcomes are, is going to be a little bit different. But normally, the trend that you'll see with some of those other ones is that normally people's HDL, their good cholesterol, goes up on the low carb diet. So this is all for low carb diet. Their HDL levels goes up, their triglycerides goes down. And again, that's a very favorable response, to have your HDL go up and to have your blood triglycerides goes down, because those are strong cardiovascular disease risk factors. And then with LDL, LDL, because a lot of people have a strong opinion with LDL. Some people say LDL is, kind of the main risk factor for cardiovascular disease, and some people think it's an overestimated risk factor, and you shouldn't be concerned about your LDL levels. I mean, I think it's a lot of these studies, they get what's known as just your the LDL through the Friedwald equation. So it's just something that's calculated, which is not that great. I mean, if you really want to look at better indications of your LDL levels, you want nuclear magnetic resonance imaging to get an actual LDL particle number, so your LDL-P, and then also the actual size of those LDL particles. And that's what's important, to see if you have the actual diameter of that LDL particle. Is it more large, more buoyant? Because that seems to not be that harmful. But is it more small, dense? The small, dense LDL particles, that's more harmful. That's more prone to oxidation, setting off this kind of inflammatory cascade, leading to atherosclerotic development. So that's what I want to look at. And so if those studies with low carb that have looked at those particle sizes, they normally find it results in reductions in the small, dense LDL particles, or an increase in the size of the LDL particle, becoming more of that pattern A, more larger, more buoyant, that's less able to penetrate the arterial wall as a result. So that's with that. And then we also have markers of inflammation. Normally, studies that measure that, CRP or other markers of inflammation, whether it's tumor necrosis factor alpha or IL-6 or whatever other marker of inflammation, normally is decreased with low carbohydrate diets. Again, blood glucose, again, glycated hemoglobin significantly reduced, fasting insulin reduced. So if you look at the, and I'm sure I'm leaving maybe some stuff out, if you look at the overall cardiovascular profile, because that's what you should look at, right? The weight, but then all these other things that I just talked about. You should look at the overall profile. So the overall risk is going to be decreased, because if all those things goes in a favorable direction, so then therefore the overall risk will be lowered. So that's kind of the overall effect from a cardiovascular perspective, in any case, that you'll find from these studies. Obviously, that doesn't necessarily mean that each person is going to have that effect, right? Each person is a little bit different, so each person might see a slightly different effect. However, if you look at the just on average, the average response is kind of as what I just noted, which again is very favorable. All right, so next meta-analysis is entitled "The Effect of Low Carbohydrate Diets versus Low-Fat Diets on Metabolic Risk Factors," a meta-analysis of randomized controlled trials. Conclusion from this meta-analysis is that they say low carbohydrate diets had beneficial effects on weight loss and metabolic risk factors, and these effects were comparable to those seen on low-fat diets. These findings suggest that low carbohydrate diets can be recommended to obese persons with metabolic risk factors. Next meta-analysis here by Bernstein and colleagues, entitled "A Dietary Intervention for Overweight and Obese Adults, Comparison of Low Carbohydrate and Low-Fat Diets," a meta-analysis. Conclusion here was that low carbohydrate diets appear to achieve greater weight loss and reduction in predicted risk of atherosclerotic cardiovascular disease risk events compared to low-fat diets. And then last meta-analysis here by Mansour and colleagues entitled The Effect of Low Carbohydrate Diets versus Low-Fat Diets on Body Weight and Cardiovascular Risk Factors. Again, another meta-analysis of randomized controlled trials. Conclusion, we found a greater weight loss in subjects on the low-carb diet compared with the subjects on the low-fat diet. So I think we've seen that pattern now in numerous other meta-analyses. And they also continue by saying, again, more favorable changes in HDL cholesterol. Again, HDL levels normally go up, and then triglyceride levels, again, triglyceride levels normally go down. So here's just a list of other meta-analyses that are out there that compared low-carb diets, again, less than 130 grams of carbohydrate per day, to low-fat diets of less than 35% fat of total calories. So you can see, and some of these I've shown you in the last couple of slides, but again, there's more meta-analyses out there. And the point of me showing you this and just quickly reviewing the results from these meta-analyses is kind of twofold. It's to show you that there is an enormous amount of scientific evidence out there regarding low-carb diets, and some of these meta-analyses just looks at the efficacy of low-carb diets. But again, a lot of these meta-analyses directly compare the RCTs of low-carb diets, and they put them head-to-head to low-fat diets. So, plethora of scientific evidence. So, this is clearly not a diet that is lacking evidence, because that was what we started off with. The idea is that this is a fad diet, or it is not substantiated by scientific evidence. There's a shortage of evidence behind it, right? So therefore, we cannot recommend it because there's too little evidence behind it. Well, I think we can put that to rest. The fact that there is a lot of studies, and if you again, as I mentioned earlier a couple minutes ago, there's normally a trend that you'll see, especially in the trends that compare the studies that compare the low carb to the low fat, the prudent, right? It's a prudent low fat diet, the diet that we were told to follow over the last couple of decades. It doesn't look so prudent, right? It doesn't it doesn't come in first. It usually comes in second when compared to the low carb diet. I mean, low carb diet generally results in more weight loss, greater weight loss, or statistically significantly greater weight loss, and it usually results in more favorable cardio metabolic profile. So again, hopefully that puts that concern at bay in terms of the scientific evidence, the efficacy, the amount of evidence. It's all there. It's readily available. It's out there, and that's why I put it here for you. And we're welcome to go look up each one of these studies and evaluate the evidence for yourself. But what I'm going to do next, I'm going to switch away from the meta-analyses. Because one thing with the meta-analyses, I mean, they're good, but they kind of get a little bit foggy, a little busy, because it's comparing a whole group of studies, and so what I want to show you next are just some very well-controlled, randomized controlled trials that, again, that specifically compare the low-fat diet to the low-carb diet. So here's a study that was published in 2008 in the New England Journal of Medicine entitled Weight Loss with a Low Carbohydrate Mediterranean or Low Fat Diet. So just a couple details about this study, or a couple things that I think make this study pretty good, is the fact that it had a fairly good sample size, just over 300 individuals. The fact that it had three separate kind of arms of the study. You had a low carbohydrate group, you had a Mediterranean group, and then you had a low fat group. So we're comparing three different diets. And then the other great thing is the study duration, the study length. It was 2 years. And you might go, well, 2 years, well, that's not that long, should have been 5 years or 10 years. Well, if you've ever done a nutritional interventional type of study, it's hard. It's hard to prescribe a diet to a group of individuals and then ask them to follow that diet and adhere to that diet for any length or period of time. So the fact that they got over 300 people, and they randomized them to these 3 different diets, and they got their subjects to stick with it and had good adherence. That's really good. So that's why I wanted to show you this study. So specifically, they got 322 obese individuals, and they randomly assigned them to either a calorie-restricted low-fat diet, a calorie-restricted Mediterranean diet, or an unrestricted low-carb diet. So if you hear that correctly, 2 of these 3 diets were calorie-restricted, the low-fat and Mediterranean. It was between 1,500 and 1,800 calories per day. And then, and again, obviously, so, low fat is kind of just your standard low fat diet, less than 30% of energy from fat. Mediterranean diet, they gave them a little bit more, olive oil and nuts. So it was a little bit higher in fat, but not nothing, maybe like 35%, something like that. And then but again, it was energy restricted, the Mediterranean diet as well, between 1,500 and 1,800 calories. But then the low-carb diet was not. It was unrestricted. So there was no calorie cap put on it. So it's basically eat kind of what's known as ad libitum, which I think is preferable, right? People don't like to eat a certain calorie limit. I think if given a choice, right? If given a choice, most people will prefer a calorie unrestricted type of diet. And that's, it's interesting if you get into this type of literature. A lot of these diets, the low-fat diets, is a calorie restricted diet where people have to adhere to, say, like a 1,500 calorie restricted low-fat diet. But a lot of the low-carb trials is normally just unrestricted. So it's just kind of eat as you want to, right? So eat when you're hungry, don't eat when you're not hungry. And I think that's another big advantage with the low carb diets, because a lot of people report that they feel full. They feel full, and they don't feel the need to eat so often. So it helps with satiety, right? Because if you want to understand obesity, you have to understand why that person is always hungry. And that has to do with what we talked about earlier when we briefly reviewed kind of the kind of etiology of obesity. But that's very important. And the fact that low carbohydrate diets kind of fixes that problem of hunger is really important. Any case, I digress. Going back to this study, so there were these, over 300 obese individuals were randomly assigned to these one of these 3 diets, and then they followed them over the course of 2 years. Obviously, they got measurements in terms of weight, but they also got some other measurements in terms of getting indication of their cardio metabolic health. Just in terms of weight loss, so the low the low fat group lost about 6.4 pounds. The Mediterranean group lost about 9.7 pounds, and the low carb group lost 10.3 pounds. So in terms of who lost the most weight, it's the low carb group first, and then the Mediterranean group, and then the low fat group. And you can see that I included some of the figures here from the study on this slide, and you can see there that the low carb and the Mediterranean they did much better compared to the low fat diet. And another interesting thing, because if you look at that figure, you can definitely see initially after the first couple of months, right, the low carb group definitely lost a lot of weight, but then it seemed to kind of come back. They still lost more weight compared to the other groups, but it seems like their weight kind of came back, and there's a reason for that. If you look at the study, some of the details in terms of the diets for the low carb group, for the first couple of months, they had to restrict their carbohydrate intake to 20 grams per day. I think it was for the first 2 months. So the first 2 months, keep your carb intake to 20 grams per day. But after that, they allowed their subjects to slowly reintroduce carbohydrate intake up to 120, 130 grams per day. And so it's interesting that initially they really restricted. So they were basically on a ketogenic diet initially, but then after that first couple of months, they brought back the carbohydrate intake, and not surprisingly, their weight started to go back up. So that explains the weight. And I think the other thing with that is, each it would appear that each person, depending on your level of kind of insulin sensitivity, you have your own kind of carbohydrate threshold. Maybe for me it's 100 grams per day. Maybe for another person it's 30 grams per day. But everybody, you're gonna have to find your own kind of carbohydrate tolerance, or your carbohydrate limit, where you feel good. And maybe initially your carbohydrate intake is low to lose weight, but then it's hard to eat, say, 20 or 30 grams of carbohydrate per day. And then if you want to kind of reintroduce carbohydrates again, you got to be, do it, maybe in small increments to see, up to what point, what is your carbohydrate threshold? Up until what point can you increase or not increase any further without seeing further increases, say, in or increases in weight or deterioration in health. So I think that's kind of an important side point. So yes, in terms of weight loss, low-fat diet, a third, low-carb diet came first here. And then I also looked at some other markers of health. And again, this is kind of what we talked about earlier. There's definitely a pattern that emerges here. HDL cholesterol was highest for low carb. Triglycerides was lowest for low carb. Especially again, if you look there at the figure after the first data collection point, or here at the 6-month mark, you can see blood triglycerides for the low carb group drop by about 40 milligrams per deciliter, but then you can see it came back up again because they were allowed to eat more carbohydrates. LDL, and this LDL cholesterol was better with the Mediterranean diet, and in this case low carb second, and then low fat again third. However, again, that's LDL cholesterol, as most studies that's not as most studies are when they measure LDL cholesterol, it's a calculated number coming from the Friedwald equation. It's not measuring LDL directly through a nuclear magnetic resonance imaging. So just throwing that out there. And then the last one that you see in our figure, the ratio of total cholesterol to HDL cholesterol. That's also a good. It's been shown in the literature to also be a pretty good marker of cardiovascular health. And again, that was also the better or the best on the low carb diet. So again, first randomized control trial here that I want to show you. Again, as you can clearly see, great study with the sample size, with the 3 different diets, and with the 2-year duration. So these are the types of studies we should look at, and we should really look at the results and the implications of the results, right? Because the prudent diet, the low-fat diet, did the worst. Right? If you were to choose a diet in terms of for your health and well-being, you should always choose a diet whichever one you prefer or you can stick to. But in this case, the low-fat diet, the one that's been recommended, because that's the point, right? It's been recommended to us for so long, for decades, and again, this was published in 2008, so just over a decade ago, and we can clearly see there was clear differences, right? Pretty clear differences from a weight and cardiometabolic perspective. So the data speaks for itself, right? I mean, I'm a data guy. I mean, and everybody should be looking at the evidence, right? So if the low-fat diet outperformed the other diets, I mean, that's a good finding. It should be your decisions should be data-driven. But again, in this case, as with a lot of other studies, the low-carb diet did better compared to the low-fat diet, and also in this case compared to the Mediterranean diet. So here's another randomized controlled trial entitled The Effects of a Low Carbohydrate and Low Fat Diets. So in this study, the objective was to examine the effects of a low carbohydrate diet compared to a low fat diet on body weight and also cardiovascular disease risk factors. So they got close to about 150 men and women were recruited for this study, and subjects in this study were without any clinical cardiovascular disease and diabetes. And then subjects were randomized to one of these two interventions. Again, either the low carbohydrate diet or the low fat diet. Specifically, the low carb diet, the specifics there is that they had to eat less than 40 grams of carbohydrate per day. So less than 40 grams of carbohydrate per day. So it was basically a ketogenic diet. And then for the low-fat group, they had to consume less than 30% of their total daily energy intake from fat. So for the low-fat diet, it was just a typical low-fat, high-carbohydrate diet. And both groups received dietary counseling at regular intervals throughout the trial. And so they got data on weight and cardiovascular risk factors and dietary compositions at baseline, at 3 months, 6 months, and then 12 months. So this was a 1 year randomized control trial. So again, from a dietary perspective, it was a nice long study duration. And so what happened in terms of weight? I think by now you kind of probably know what happened to their weight, but specifically at 12 months, participants in the low carb group had greater decreases in body weight. The difference was about close to 4 kilograms. There was also a difference in fat mass as well, so they measured that. The mean difference in terms of the change between the two groups was 1.5%. And then they looked at some other cardiovascular disease risk factors. Again, HDL was higher in the low carb group. The mean difference was 7 milligrams per deciliter, so that's a nice increase in HDL for the low carb group. And then triglycerides, again, significant reduction in triglycerides for the low carb compared to the low fat group. Mean difference was 14 milligrams per deciliter. And then they also again looked at this other biomarker of this total cholesterol to HDL ratio. And again, that was also significantly better at 12 months for the low carb compared to the low fat diet. So another good study with a good sample size, with a good follow-up period, 1 year, and again, just comparing two very different diets to each other. And again, it's about both diets, right, improved subjects' health because they lost weight. And you have to understand, kind of where I'm going with this is, low fat diets, low-fat, high-carbohydrate diets that are prescribed in a study, it consists, fruits, vegetables, grains, that kind of thing. So it's not, the low-fat diet that people typically consume outside the kind of study setting, right? Because, the type of carbohydrates that people are typically consuming just in a real world environment, right, when they're not in a study, is not fruits, vegetables, that kind of thing. They might be consuming some fruits and vegetables, but a lot of the carbohydrate is coming from it's the processed carbohydrates, right? It's the sugar, it's the candy, it's the sodas, it's the cakes, it's the pizzas, etc., etc., etc. So just I want to make that distinction, and because it's really those foods, the food items that are high in sugar, flour, grain, is those highly processed carbohydrate food items, and that's the worst. I mean, if you eliminate, because in addition to that, they also contain, they contain fat, but the fat that they contain is it's these trans fats and vegetable oils. And if you eliminate that from your diet, I mean, your health is going to improve, right? You'll lose weight and you'll feel better. And whether that's on a low carb diet or low fat diet, if you eliminate those products, then you're going to be doing better. So I just wanted to make that distinction. And I think it's an important distinction to make within a study, because that's what we're looking at here. We're looking at randomized controlled trials, and subjects are involved in a study, and you're monitored pretty closely in terms of what you're eating. And so the researchers are not prescribing to their subjects cakes and cookies and French fries and that kind of thing. I mean, that's not the low fat high carb diet that people are on in studies. But again, even though both groups, right, are eating a healthier diet compared to what they would in the real world, again, the question, you go back to, which one did better, right? And again, in this particular investigation, as we have seen with some of the other studies, the low carb diet, right, comes out top again. And again, the reason why that probably happens in most of these studies is because if a lot of the people that's recruited for these studies, or if you look at the subject characteristics, people are overweight, people are obese, people have, say, prediabetes, diabetes, so they have some form of chronic disease, and you should always look at the subject characteristics. So just throwing it out there, in most of these studies, the subjects that are recruited, have, say, a BMI over 25 or over 30, or again have a particular chronic disease, and therefore they are probably insulin resistant. And because that's the case, and again, that's the case for the majority of people in the US, but probably also globally, because they're insulin resistant and they now go in this type of study, it's not surprising, not any case to me, that everything normally goes better for them when they are assigned to a diet that restricts carbohydrate the most. So I think that's an important point and something to think about. So here's another very interesting randomized controlled trial known as the A to Z weight loss study. And it's entitled Comparison of the Atkins, Zone, Ornish, and Learned Diets for Change in Weight and Related Risk Factors Among Overweight and Premenopausal Women. So for this study, they got just over 300 overweight and obese premenopausal women, and they randomized them to these 4 very popular diets. Again, either a low-carb kind of Atkins diet, a low-fat vegetarian Ornish diet, the Zone diet, and the Learned diet. And the Zone and the Learned diets were calorie restricted. And again, so subjects in the study, they were given a diet book, because, and this is why I said it's kind of real world, because a lot of people, they who want to lose weight, they go out there and they go get a specific book. Maybe it's the Atkins book or Dean Ornish book or whatever other diet book, right, that is out there. And these are 4 popular diets. And so that's what happened in this case, and people also received counseling on how to follow the different diets. But again, you have, for example, 2 diets here that's very different than one another. Again, the low-carb group, or kind of the Atkins group, because the Atkins diet is a low-carb diet, it's pretty low in carbohydrate content. Now you compare that to the Ornish diet. The Ornish diet is very low-fat. You have kind of the typical low-fat diets, less than 30% energy from fat, but the Ornish diet is like 10% of energy from fat. So it's 2 really completely diets in terms of where the energy is coming from. And the other good thing about the study is it was 1 year in duration. So I included a table here that shows you the results in terms of what happened with body fat, weight, LDL cholesterol, HDL cholesterol, triglycerides, and systolic blood pressure as well for, again, these 4 different diets. And you can see how many people were randomized to each diet. You can see it was about 80 people were in each group. And you also see there under each outcome or dependent variable, you'll see 2 months, 6 months, and 12 months. So that's when they got the data, and so you'll see the difference. It's nice because you can see the difference for all these variables at those different data collection periods. But so here's really what happened, because as you can imagine, there were differences here between the different groups. But let me just highlight the difference between the low carb or the Atkins group and the Ornish group, since those two are so completely different. So if you look at systolic blood pressure went down close to 8 millimeters per mercury on the Atkins diet, and it went down only 1.9 millimeters per mercury on the Ornish diet. So that's a pretty clinically significant difference in systolic blood pressure between those two groups. Diastolic blood pressure went down 4.4 milligrams on Atkins, only 0.7 on Ornish. HDL, right, the good cholesterol, you want it to go up, right? It went up by about 5 milligrams per deciliter on Atkins, and it really didn't change at all on the Ornish diet. And then the blood triglyceride levels, you want it to go down. It decreased, close to 30 milligrams per deciliter on the Atkins diet, so a really substantial decrease in blood triglycerides, and it went down by about 15 milligrams per deciliter on the Ornish diet. So, and in terms of weight, right, if you just look at percent body fat, right there, the first column there on top of the table that I showed you at 12 months, in terms of percent body fat, again, the Atkins was close to 3%, Zone 1.3%, Learn 1%, and Ornish 1.5%. So in terms of who lost the greatest percent body fat, again, it was the Atkins. So I mean, it's really everything here went in the right direction for Atkins. So if you wanted to pick here out of these 4, right, because there was these 4 that were studied in this particular study, which diet came out on top, it was the Atkins diet. And that should probably, again, as I said in the previous slide, this probably should make sense, because who was the subject population? That's something you should go back and look at. Well, it was just over 300 overweight or obese women. So these are people who were clearly insulin resistant, or fall on that kind of one side of that insulin resistant spectrum. And so therefore, if you're insulin resistant, right, you have some form of carbohydrate intolerance. So that's the underlying condition. And if you understand that, how do you treat that underlying condition? You restrict your carbohydrate, because if you restrict the carbohydrate, then all those other symptoms would go away, and the blood pressure comes down, and the weight comes down, and everything else just improves. And so hopefully that's a theme that has started to emerge now, and you can see that by looking at all these different studies that I'm showing you. So lastly, here's a great study out of Jeff Volek's lab. Dietary carbohydrate restriction induces a unique metabolic state, positively affecting atherogenic dyslipidemia, fatty acid partitioning, and metabolic syndrome. So what they did over here in this study, they got a group of people with metabolic syndrome, 40 subjects, so clearly insulin resistant, because again they have this metabolic syndrome, and they randomized them to again, these 2 diets, either high carbohydrate, low fat diet, or a low carbohydrate, high fat diet. But the nice thing, interesting thing about this study is that both of these diets were similar in the number of calories. So they were kind of isocaloric. So both provided about 1,500 kilocalories per day. It's just that where the calories were coming from, again, were completely different. So another good study to show you, it's not about the quantity of the calories, it's really about the quality. Since with the high carb group, right, the majority of the calories came from carbohydrate, and with the low carb groups, only 12% of the calories came from carbohydrate, and 60% of the calories came from fat. So it was a ketogenic diet. Study length or duration was 12 weeks. So it was a 12-week study. Now, as you can see here from the figure that I included here from the study, they measured a bunch of variables. They looked at body mass, abdominal fat, glucose, insulin, leptin, triglycerides, HDL, small dense LDL particles, ApoB to ApoA ratio. So a whole bunch of variables that has to do with body composition, and then markers looking at kind of cardiometabolic indices. So as you can see from the figure, the low carb group basically lost twice as much weight. So there's twice as much weight loss on the low carb group compared to the low fat group. That's not all. If you look, for example, at LDL, right? Because a lot of the other studies that I've showed you, if they did measure LDL, it was calculated LDL. It wasn't actually looking at the different particle sizes. And so LDL particle size, basically it went from pattern B to a larger size LDL particle. And that's kind of the profile that you want. But again, if you just look at the small dense LDL particles, you can see it went pretty significant decrease on the low carb diet. For the high carb diet, there was actually an increase in the small dense LDL particles, so that's not what you want. If you look at HDL, right, you want it to be high, and again, it was about a 13% increase in the low carb group. So that's perfect. That's exactly what you want. But again, if you look at HDL, you can see for the high carb group, you can see it actually went down a little bit. So that's not what you want. Triglycerides were basically cut in half in the low carb group. So huge reduction in triglyceride levels. Now, the other thing from the study, there was really no relationship between dietary saturated fat and blood saturated fat. When looking, especially at the low carb group, right? Because the low carb group, they're eating a high fat diet, and that means they're getting in significantly more, not just fat but saturated fat compared to the low fat group, and saturated fat, dietary saturated fat, there's nothing wrong with that. Or if you look at dietary saturated fat as being a risk factor, again, there's been review articles looking at that as well. But blood saturated fat, I mean, that's a good strong predictor of cardiovascular disease. And so you go, well, these guys, the low carb guys, right, they're eating a lot of saturated fat, so is that going to increase their blood saturated fat? But again, there was no relationship between dietary saturated fat and blood saturated fat. So, and in addition, I mean, again, the low carb diet had 3 times as much saturated fat in it, and so why was their blood saturated fat so low? Well, the answer is that they are probably burning it very fast, right? When you adapt to a low carb diet, you become a pretty good fat burner, and a class of fats that are preferentially mobilized and oxidized are those saturated fats. So therefore, it doesn't accumulate, it doesn't cause any harm, right? I mean, that's just what happens. I mean, you that's the whole idea behind low carb diets, is you restrict your carbohydrate intake, and then your body, instead of burning carbohydrates, it starts burning fats, and you start burning your own body fat. But then again, in terms of the fat that you're also ingesting, or the saturated fat, again, there's no relationship between the dietary saturated fat, blood saturated fat. It's not sticking around. Why not? Because it's being oxidized, it's being burned for fuel. Okay, and then the last thing about this study, they also looked at a bunch of inflammatory biomarkers. They measured like a panel of 14 of them, and on the low carb diet, 14 out of 14 were reduced. On the high carb diet, only 6 out of the 14 were reduced. So therefore, you could say that a well-formulated ketogenic diet can be profoundly anti-inflammatory. Inflammation is not just about heart disease anymore. It's the root cause of many chronic diseases. So so a good study to show us, not just the weight and some of these other factors improving, whether it's the HDL, the triglycerides, or the LDL particle, but inflammation, again, root cause of many chronic diseases, improving a lot. So with the low carb diet, so that's why I said it seems that nice thing about a well-formulated ketogenic diet, it seems to be profoundly anti-inflammatory as well. Alright, so lastly, let me finish with this. Up to this point in time, there's been a total of about 62 randomized control trials that have directly compared low-fat diets to low-carb diets for weight loss. And really, the results speak for themselves. Out of those 62 RCTs, 31 out of 62 resulted in significantly greater weight loss for the low carb compared to 0 out of 62 for the low fat diet. So out of 62 studies, 31 out of 62 resulted in statistically significantly greater weight loss for the low carb diet compared to the low fat diet. In how many of those 62 randomized control trials did the low-fat diet result in statistically significantly greater weight loss compared to the low-fat diet? The answer to that is 0. 0. So I ask you this question. Where is the evidence that eating a low-fat diet makes you lean and healthy? You have been told a lie for the last 40 to 50 years. And that lie has been, in order to make you lean and healthy, you have to eat a bunch of carbohydrates. And we can clearly see by looking at the totality of the evidence that that is not true. So where is the evidence that eating a low-fat diet makes you lean and healthy? Again, I said this in the beginning. I started off by saying you've been told a lie. And it all started here in the late 1970s with the introduction of the Dietary Guidelines. So it's time for the truth to prevail, right? Because the truth shall set us free. Alright, so if you're sitting there and you're going, well, I think I want to try a low-carb diet, but I'm not quite sure, what does that look like? So what does a low-carbohydrate, high-fat diet actually look like? Because a lot of people have misconceptions regarding low-carb, high-fat diets. I mean, I have people coming up to me or emailing me all the time saying, well, can I eat fried chicken? Can I eat nachos and ice cream and pizzas and cookies and all this other stuff? I'm going, no, that's not a low carb, high fat diet. It's more like the standard American diet, right? Because I mean, the standard American diet is high carb and high fat. It's high sugar, and the fat is not natural fat. It's kind of these seed oils or these vegetable oils. So basically, I mean, again, and there's a lot of great resources out there, a lot of great websites and books that you can read that gives you a good indication about a low carb diet looks like. Dietdoctor.com, they have so many good resources and recipes and foods with pictures and just great stuff. Breakfast options, lunch options, dinner options, snacks, desserts, all kinds of stuff. So definitely a website to go check out if you're interested a little bit more about low carb diets. But really, if you just kind of want a quick overview in terms of what low carb diets looks like, well, it involves eating real foods. Okay, it involves eating real foods, and that's why I like this quote that you see up here by Peter Cleve. He said, "For modern diseases to be related to an old-fashioned food is one of the most ludicrous things I've ever heard in my life," and I would agree. So, low-carb diet includes eating meat. Any type, really, including beef, pork, game, meat, chicken, etc. Feel free to eat the fat on the meat as well as the skin on the chicken. If possible, try to choose organic or grass-fed meat. It involves eating fish, shellfish, fat, especially fatty fish, salmon, mackerel, herring. Those are great options. Eggs, of course, a great breakfast option, and again, really all kinds, boiled, fried, omelets, etc. Natural fat, If you're cooking, butter, olive oil, coconut oil is great for cooking options. Vegetables, the non-starchy vegetables, those typically are the ones that grow above the ground. Cabbage, cauliflower, broccoli, Brussels sprouts, asparagus, zucchini, eggplant, olives, spinach, mushrooms, cucumber, lettuce, avocado, onions, peppers, tomatoes, etc. So many ones to choose from. Because again, it's another thing, people think low carb diets doesn't include a lot of vegetables, and that's not the case at all. People get a lot of vegetables and fiber from low carb diets. Dairy products, with the dairy products, you always select the full fat options. Nothing low fat. Anything low fat is just high sugar. So whether it's sour cream, Greek yogurt, high fat cheeses, milk, don't no skim milk, just full fat milk. Something to snack on, right? Nuts is a good option. Almonds, macadamians, walnuts. Berries are pretty low carb in terms of for fruit, right? Blackberries, raspberries, strawberries, avocado. Also. To drink water, coffee, tea, just no added sugar, right? But you can add some full fat cream if you want. So that's just kind of, like I said, a very brief, very simplistic overview kind of a low carb diet. But again, go check out some other sources like dietdoctor.com if you want a kind of a more detailed view of just more options with low carb diets. All right, and then lastly, here's just the basics of good nutrition summarized. So if you take anything out of this talk, let it be this, right? Number one, eat whole, unprocessed foods, meaning eat real foods. There's so much fake foods out there, it's unbelievable. I mean, you know it. I mean, every time you enter the grocery stores, the shelves are just packed full of fake foods. Everything is in a box. A lot of stuff says low fat. That's not what you want to do, right? You want to eat whole, unprocessed, real food. Avoid sugar. Try to restrict sugar out of your diet by as much as possible. Right, so if you buy an item, right, look at the not just the carbohydrate content, but how much sugar is in there. A lot of people are completely fooled in terms of how much sugar is in their drinks or food items. And that's why most people consume 30, 40, 50 teaspoons of sugar a day. I mean, I'm doing a study have been doing a study here at Grove City College for the last couple of years, and it's very simplistic, and we see how people eat and then how it impacts their health. But when we get people's dietary information and I review it with them, people are absolutely shocked when I tell them, do you know that you're ingesting the equivalent of about 50 teaspoons of sugar a day? I'm like, no, I had no idea. That's not good. That's what happens. I mean, just the sugar, the sugar is hidden. And a lot of times people have no idea how much sugar they're ingesting on a regular day, right? Because most people start off their day with some type of cereal that they think is healthy because it probably on there it says something about it's a whole grain or it's going to lower your cholesterol, but it's got a lot of sugar in it, and maybe some orange juice or some type of juice that has a lot of sugar in it, or some pastry, and then maybe for again for lunch, maybe a soda comes in, or some snack, or some energy bar or energy drink, or a lot of maybe sugar is put into, say, the coffee or the tea. So again, you can see how easy just throughout the day with the meals and the snacks, the sugar amounts can just easily start to add up. So try to restrict the sugar in your diet by as much as possible. In addition, avoid refined grains. Again, there's a lot of items out there. The sugar, flour, grain-based products, those processed carbohydrates is going to have a big impact on your glucose and insulin. Eat a diet high in natural fats. Hopefully you saw by the research that I showed you, there's nothing wrong with eating a diet high in natural fat. There's everything wrong with eating a diet high in unnatural fat, which a lot of us are eating. If you're eating the standard American diet, your diet is high in unnatural fat. So a lot of the processed foods, the fat that is in there is not natural. It's like I said, it's processed seed oils. So that's not good. But if you're eating, natural, fats, that includes saturated fat. I mean, there's nothing wrong with that in the context of a low carbohydrate diet. And then lastly, we didn't really get to talk much about this, but balance feeding with fasting. Again, it's not necessary to eat 10 times per day, right? I think most people know that. But again, like we said earlier, it's not just the problem. It's not just macronutrient, composition. It's also meal frequency, and we're eating a lot more than what we used to eat, right? So I mean, the further you go back in human history, I mean, just most people are eating maybe once or twice throughout the day. So I think cutting back on the snacking and just going back to something like whatever works for you. If it's if you feel like eating once a day or twice a day, or maybe it is 3 times per day, then that's optimal. And obviously then in between you are you're fasting. And as I said earlier, I don't think it's necessary to to fast for 2 or 3 or 4 days. Some people do that. I don't think that's necessary, and there's debate whether that's good or not in terms of if you're losing your metabolism and if you're losing muscle mass. But again, I don't think that's necessary. I don't think it's necessary to be eating constantly throughout the day. So again, balance feeding with fasting. So there you go. So hopefully those are some things that you can take away from this talk, and that can be helpful as you move forward. So in conclusion, we have a chronic disease epidemic in this country, but also globally. And we have to understand that diet is the ultimate cause. We typically refer to these as lifestyle diseases, but more importantly and more accurately, these are dietary diseases. Now, unfortunately, many public health officials and organizations are providing the public with the wrong messages, especially as it relates to nutrition, saying that you have to eat less fat because fat's going to make you fat, and fat, especially saturated fat, is going to lead to heart disease and cancer and many other horrible things, saying all calories are equal, saying that you can eat whatever you want, just make sure you're active, so then you can outrun your horrible diet, etc., etc., etc. It's those types of messages that is partially responsible for why we're in the mess that we are currently in. And that's why I like that quote that says that everyone is entitled to his own opinion. And yes, that is true, right? Everyone is entitled to his or her own opinion, but not to your own set of facts. The facts matter. In the field of nutrition, I mean, if you spend some time in the field of nutrition, number one, everybody's an expert in nutrition. I think you probably know that. And but the other thing is that there's a lot of opinions going around in nutrition, but there seems to be very little fact. I think few people are actually looking at the science that is out there. And I showed you a little bit. The goal was to give you a little snapshot of the scientific literature that is out there. So the facts matter. The evidence matter. The totality of the evidence matter. And what we saw earlier is when we looked at the low-fat diet, and one of the goals of this talk was to show you the evidence for the low-fat diet in terms of all the way back to the beginning, kind of here in the 1980s with the inception of the Dietary Guidelines. Where was the evidence for the inception of the Dietary Guidelines? There was very little to none. And then you look, well, where's the evidence since 1980? There appears to be very little as well. You think the evidence would have accumulated over the course of the last 40 years or so, but again, those studies are lacking as well. And even if you look at the biggest study that looked at kind of the efficacy of low-fat diet, the Women's Health Initiative, I mean, it really had null findings in terms of weight over the 7-8 year period, and also cancer and cardiovascular disease they looked at as well. So really, again, the question remains, where's the evidence that a low-fat diet will make you lean and healthy? And we looked at other diets, Mediterranean diet, low-carb diet, and normally those diets fare much better compared to the prudent or standard low-fat diet. So again, that's why I said, I mean, I've said this now. We've been told a lie for the past 40 to 50 years, and we've been, this whole this kind of whole lipophobia is still ingrained into a lot of people's minds, and they fear fat for those obvious reasons that we talked about earlier. And again, that's been a big part of the problem, was the whole lipophobia that came out of the dietary guidelines, because it pushed people to the carbohydrate. And again, that's one of the big problems is we expose an insulin resistant population to these very high carbohydrate diets, and then we had the kind of the symptoms that developed from that. So it's as I said before, I mean, it's time for the truth to prevail, because I mean, truth will set us free. And so kind of just to finish off here, I'll leave you with a story, and I think it's a good analogy of our current state we face ourselves with. And this is the story of Ignaz Semmelweis, and he was a medical doctor who worked in a maternity clinic in Vienna, Hungary, in the 1840s. And many women in a maternity ward were dying from childbed fever. And he studied 2 maternity wards at the hospital, one staffed with all male physicians and the other with midwives. And what he found was the women in the clinic staffed by male physicians had died at 6 times the rate compared to midwives. And the difference was that male doctors were doing autopsies, the midwives were not. And this was before there was any knowledge of bacteria or the microbial world. And after this discovery, he instructed the medical staff to start cleaning their hands and instruments with chlorine. Kind of seems obvious. And if they followed his advice, most of the deaths would have been averted if the doctors, actually just washed their hands. The problem was that the doctors were very upset because he made it look like they were the ones giving patients childbed fever. So what happened? Well, no one listened, and they could not conceive that they were the ones actually killing their patients. So why is this story applicable to today? Because I believe that the same applies to our current nutrition guidelines, or at least as it stands today. And as we saw in over the course of this talk, of this presentation, low-fat diets has been prescribed and recommended for the last 3, 4, 5 decades, and has clearly done more harm than good. And the reason the medical profession don't accept this is called cognitive dissonance, right? It's too painful for the people in the medical field to accept that what they're doing is wrong, and it's actually harming, in some cases, actually killing their patients. So they just rather forget it, pretend that it doesn't exist. And right, and remember that quote I showed you at the beginning of this presentation by Barry Marshall, and he said every generation of medical students is taught at least one utterly wrong fable. And I believe the big fable of this generation has been that low-fat diets are best, and we are all meant to believe that there's only one diet for weight loss and health, and that's supposedly the low-fat diet, and obviously that's clearly is not the case. So in conclusion, the current dietary guidelines, right, based on lipophobia, the fear of fat, and they're again not at all evidence-based. Adoption of that 1977-1980 dietary guidelines caused the global epidemics of obesity, and then the type 2 diabetes epidemic that began soon afterwards. And again, this can be explained when you expose those with insulin resistance to inappropriately high carbohydrate intake. And hopefully I made the case for that. When we said that it would appear that a lot of people are insulin resistant, or currently over 50% of the population are insulin resistant, so meaning they're carbohydrate intolerant. So therefore the solution from a dietary perspective that would clearly work for most, not necessarily all people, but would clearly work for most people, is some form of carbohydrate restriction. Hopefully, that becomes clear and obvious. So, I mean, really the opportunity that we have before us is enormous, because now we have the possibility to cure or reverse many of these diseases that has been seen for a long time to be, incurable and just progressive in nature. And this is an incredible notion. And, it's available to all of us without any drugs or without any surgery. Or if you choose to do some form of fasting, could also be no cost. And that's kind of the whole idea behind this presentation is that these diseases, right, they cause so much pain and so much suffering for so many people, right, millions of people. And we have treated these diseases for so long with the wrong paradigms and the wrong treatments. And, these are dietary diseases. Therefore, they demand a dietary solution.